Hello, all dear students. Welcome to this SOM marathon session where we will be telling you the last 5-year previous year questions for civil engineering for both the sets. That is 2019, 2020, 2021, 2022, and 2023. In every of these 5 years, civil paper, GATE previous year paper was come in 2 sets, forenoon and afternoon. That means today, both of us, me Abhinav Negi from Delhi and Dheeraj sir right now in Hisar, will be solving 10 previous year questions for strength of material subjects. And as you know that this is the previous year question series for last 5 years, we will be doing for other subjects also. Like in Saturday, I'll be doing for surveying. Saturday, I'll be telling you for geotechnical last 5 years, then Sunday surveying, and Sunday also mechanical SOM will also be there. So all the students who are from civil or mechanical can come in today's session also, because that will be helpful for them. All the mechanical students can help get this. And similarly, all the civil students today, they should be coming in the mechanical Sunday session also. In fact, that will be much more beneficial because your previous year questions of your branch, you will be many times familiar with them or many times you have solved them. But civil students, have they solved mechanical? Chances are less, and vice versa also. So it is very important to attend that also. Okay, so come all MCQ, MSQ, NAT, everything we'll be doing today, and we'll be going in a serial order. Okay, like we'll not be doing anything random. First of all, we'll be completing all 2019. Okay, me and Dheeraj sir both. Then we'll be covering 2020, then 2021, then 2022 and 23. Okay, now let's go to the master blaster himself, the man of strength of material, the champion, the commando, Abhinav sir. Sorry, Dheeraj sir.
Sir, thank you, sir, for that wonderful introduction. So, guys, as sir already told you that this is going to be equally important for mechanical civil. Even I have seen that if you see the paper of XC, mechanical and civil, you will find that questions are repeated many times. So civil questions sometimes comes in mechanical, sometimes comes in XC. XC question sometimes comes in mechanical, sometimes comes in civil. So guys, that is why it is going to be equally important for all of you. And 95 to 99% syllabuses are also ekdam same hai bilkul. Only one topic here and there is there. So that's why it is going to be equally important for all of you. And we will be going with wonderful explanation, and whatever is required for interview purpose, that also will be covered with the questions, because you will be getting a benefit over, you can say, others at that time also. So we are starting the session without wasting the time. So sir.
Okay, this is about me, guys, and this is the workshop that I'll be taking on 13th of June. Okay, this is the super duper workshop. 7 key factors that transforms an average student to a GATE topper. Okay, so average student to a GATE topper. This will be 7:30 p.m. on app. Please do register for this workshop. Now, this is the ISRO practice course that our mechanical team is coming. Okay, this will be starting from 10th of June. And in this session, 3 days a week, that is Monday, Wednesday, and Friday, you will be having the practice questions. And then on the weekend, you will be having the previous year question paper solution. Okay. Dheeraj sir, anything you want to add here?
So guys, like we have already taken some PYQs. And when we were taking the PYQs, many students requested for the revision and practice series, because you want to see some other questions, because PYQs definitely you have to do, but other than that, what you can do subject wise. So for that, we are coming up with this series where we will be covering subject wise 50-70 questions, so that you get to know what other questions can be there in the examination. Also, we will include aptitude part, and we will go as per the new pattern rather than the old pattern. PYQs are based on previous pattern only. So that new pattern, you will get to know that how it is. So it is going to be an advantageous series for all of the ISRO aspirants. Every time ISRO comes up with that much number of vacancies, even if you are targeting ISRO next year, then also it is going to be very useful. And guys, this is related to CCMT. And CCMT, those who are attending the counseling, the best choices for mechanical engineering you will be getting. And I will be sharing this video. This will be in the recording format. You will get it on tomorrow. So tomorrow you can watch it. Okay. So other, sir.
Okay, guys, this is the surveying. This will be on Saturday. Then Sunday will be soil mechanics, complete 5-year questions. complete 5-year questions of serving, then complete 5-year questions of strength of material. Then guys, the mechanical, this will be mechanical. This will be mechanical 5 years previous year question, and that will be very important for the civil branch as well. So Friday, Saturday will be surveying, Sunday will be soil mechanics, then Sunday evening will be strength of materials also. Okay. Now guys, what is the average salary of MTech specialization for civil? For geotech, what is the average salary? For transportation, what is the average salary? What is for structure, what is the average salary? That I'll be telling you in the upcoming week. And is MTech from NIT worth? That also I will be telling you. This is the scholarship test. Even if you don't want to enroll the courses, you are saying, sir, you are saying the scholarship test, so the students are enrolling. I'm saying even you don't want to enroll, this is a free of cost. Okay. So this is a free of cost test. You can check your performance on the all India level. So I recommend everybody to give this test. That will be on 11th of June and 14th of June will be the workshop. The Telegram, you can join our Telegram. Okay. Now, before I start or before we start the paper, okay, one by one, we'll be going 2019, then 2020, then 21, then 22 and 23. Let me tell you, if I tell you about the strength of material weightage in the last 3 years, okay. So number of questions or number of marks in strength of material are around 5 to 6. Okay, average you can say 5 to 6 marks question will be asked. Earlier, if you see my time, 2012, 11, 13, 7, in that time, strength of material was in higher range. That means it is generally asked of 11 marks, 12 marks, 10 marks like this. But in recent 3 years for civil engineering, the weightage has been decreased. But what I want to tell you, even if SOM strength of material is coming of 2 marks, then also important will be very much, because all the subjects of civil, not all the subjects, but most of the subjects of civil, the SOM is the key. SOM is the basic physics for that. Like RCC, SOM is required. Steel, this is required. Geotechnical engineering, Mohr circle chapter, shear strength chapter, this is required. Okay, RCC. Structural analysis is pure part of the SOM का advanced part है. Structural analysis में वो चाहिए. ठीक है, RCC दिख नहीं रहा भाई, कहाँ चला गया यार? इंजीनियरिंग कहाँ चला गया? RCC कहाँ चला गया? पता नहीं कहाँ गया. RCC में पूरा आपके पास कहीं भी चला गया हो, पर RCC में पूरा आपके पास स्ट्रेंथ ऑफ मटेरियल चाहिए होता है. भाई ऐसा कैसे गजब हो गया कि RCC ही नहीं दिख रहा? ओके, ये रहा सबसे नीचे. तो ये RCC आपके पास है. ठीक है, इन सब में आपको स्ट्रेंथ ऑफ मटेरियल की जरूरत होगी. तो 5 to 6 मार्क्स आपके पास आएंगे. So Dheeraj, sir, shall we start with the first question? Okay, yes, first we'll be telling 2019, then 20. Me and Dheeraj sir combinedly will be taking 2019, then 20, then 21, then 22. Copy pen लेके बैठना. For civil and mechanical is very important. और जो संडे को होने वाला है आपके पास मैराथन मैकेनिकल का, that is also very, very important for civil also. Even I am saying the other branch marathon is more important for you, because apni branch se you will be familiar, but other branch it is still new for you. Okay, so please do watch. And Saturday I am coming with survey marathon previous year questions, then Sunday soil mechanics and so on both. Now Dheeraj sir will be taking a question, then I will be coming. Okay, for this question I will be coming. Let me switch off so that Dheeraj sir can be in the bigger screen and you can see the words clearly.
Yes,
I'm good, Arun.
Nice.
I'm good.
Yes, so guys, we are starting the question. If you see this question, for a plane stress problem, the state of stress at a point P is represented by the stress element as shown in the figure. You can see this stress element. From that, you can see sigma xx is given as 80 MPa as it is tensile. Sigma yy you can see is going to be negative. It is minus 20 MPa because it is compressive. You know, when we are talking about the shear stresses, this case we are taking it as positive shear, and this case we are taking it as negative shear. Okay, because angle is increasing here. So that is why tau xy will also be considered as equals to minus 25. That based on the sign convention, and you will find both the ways, whatever the sign convention you are using. Then, my dear, they are asking that by how much angle in degrees the stress element should be rotated in order to get the planes of maximum shear stress. So we need the planes of maximum shear stress. Now, my dear, the choice is yours. You can first go for the principal plane as well by this formula. Tangent to theta p is equals to tau xy divided by sigma xx minus sigma yy by 2. Or the second way is you can directly go for tangent to theta s. If you will go by that, you will get first of all location of principal plane. Then, my dear, to get the plane of maximum shear, you need to do plus minus 90 degree. Okay, in that, because you know, sorry, plus minus 45 degree, because you know plane of maximum shear are at 45 degree to the principal plane. So just try to solve it and give the answer. Yes, yes, yes. I am waiting for your reply, guys. Just solve it. Okay, just solve it. Yes, wonderful, guys. Okay, okay, Arun. So please try to solve it. I have already given you the way how you need to solve it. You need to just put the values now. 25, 20, 80. When you will put this, you will get the location of principal plane. Adding and subtracting 45, you will get one of the value out of these. Just try to solve it and give me the answer. I'm waiting for your answer, guys. Yes, tell me, guys, tell me. Everybody. Yes. So guys, when you will be putting the value tangent to theta p tau xy, you know tau xy is minus 25 divided by sigma xx is 80 minus of minus 20 divided by 2. When you will be solving, my dear, you will be getting the value of theta p. And when I have solved it for you, theta p, very good, very good. Vaibhav, aspirant, okay, very good. Aspirant said the answer is A, this is correct. Because whatever the answer Vaibhav is giving, that is for theta p. Here you will be getting 13.3. Okay, so when you will be using this, you will be getting the right answer. It is minus 13.3. Putting the value here, you will get the answer to be 31.7 degree for plane of maximum shear. Very good, Gargi. The answer is correct. Vaibhav, the answer is correct. So wonderful, guys. So this question was from principal stresses and strain. Okay, so we are moving to the next question. So guys, this was the next question is related to once again 2019. This is related to once again the chapter of principal stresses, or you can say combined stresses. The question says an element is subjected to biaxial normal tensile strains of this. So biaxial normal tensile strain, biaxial loading, whenever we say, is of this type. So we are given the value of epsilon xx as 0.0030. And also we are given the value of epsilon yy as 0.0020. You need to find out the normal strain in the plane of maximum shear strain. This is a very good question. And similar question have been there in mechanical paper in 2021. They have just replaced strain by stress. So that is why whatever you are going to do, inter-branch questions will help you a lot, because they will be repeated. Okay, and only data would be changed. Sometimes data is also not changed. I will show you some question in civil which directly repeated in mechanical. Some question in mechanical which directly repeated in civil. Okay, yes. So guys, this is the question. If you want some hint, I will give you in this way. Like if someone asks us, find out the normal stress at the plane of maximum shear. You know, whenever we are going to plot the Mohr circle, let us say this. So you know, plane of maximum shear is coming when we make a radius from the center of Mohr circle. So that is why this will give you the maximum shear stress. And at the plane of maximum shear, whenever we are going to write the component, you are writing sigma star, which is nothing but the coordinate of the center of Mohr circle. So this is going to be sigma star comma tau maximum. So my dear, if you remember the Mohr circle, sigma star was written like sigma xx plus sigma yy by 2. And you also know it, we can write it as sigma 1 plus sigma 2 by 2. And this would be the normal stress at plane of maximum shear. You know, whenever we are having about the normal, whenever we are having the normal and we want to find out, whenever we are having the stresses, we want to find out the strain, then what we need to do? So my dear, always replace sigma by epsilon and tau by gamma by 2. So here, if you want to find out, the normal stress at the plane of maximum shear, this was the formula. Now you want to find out the normal strain at the plane of maximum shear. So the formula will be epsilon star is equals to xx plus yy by 2. I have just replaced sigma by epsilon in this formula. So that is going to be using the concept of Mohr circle. Sir, आप civil department से है? नहीं वैभव, I am from mechanical, but SOM is a common subject. So me and Abhinav sir are taking care of strength of material for both the branches. Okay. So even for gate XC, we have done the analysis if you have seen. Okay, Vaibhav, it is not hard question. It is a, you can say, new type of question. Okay. So if you see this answer is given by aspirant as C. So when you will be putting these value 0.003 plus 0.002, the answer will be coming out to be 0.0025. Actually, what here I have done was the explanation. If you know the Mohr circle, you know this formula. Then without explanation, it is only this formula. So solution is only this much. Okay. So solution is only this much. So this was the explanation from where I get this. Okay. So the answer is going to be C. Okay. So very good, aspirant and Vaibhav, I feel you understood this question. Then we are moving to the next question. Okay. Anybody if have any doubt, please ask. Okay. So this is the next question from the thermal stresses. Next question is from the thermal stresses. When we are talking about tough or hard question in civil engineering paper, we will get 1 to 2 questions every year which are either lengthy or hard. Okay. So that is there. Okay. But that is required also. How they will judge who is going to be in the single digit rank. So for that, these things are necessary. So guys, you need to prepare good with concepts. Nobody will be facing any difficulty in any of the question if your concepts are good. Okay. Yes. So now Abhinav sir would be coming. So just solve this question. Then we will invite Abhinav sir to come for the 2019 question. This is the third question I am taking consecutively. An isolated concrete pavement slab of length L is resting on a frictionless base. So there is a frictionless base on which we are going to have, this. This is isolated concrete pavement. Okay. Then you are going to have the temperature of the top and the bottom fiber of the slab is, this is TT, this is the TB. Then they are saying given the coefficient of thermal expansion alpha, modulus of elasticity E, assuming TT more than TB and the unit of weight of the concrete is 0 and the maximum thermal stress is calculated as 1 mark question. Very easy question. What would be the answer? Very good. Aspirant have said 0 much before. Roshan also have given the answer to be 0. Yes, Vaibhav, what is your answer? Yes, what about others? So the answer for this. So very good, wonderful. So guys, here first point is when we are talking about concrete, it is not fixed from anything. Okay, so it is free to expand. So it is the case of free expansion. And second thing I would like to add, my dear, that frictionless base. So because of that, this base will also not be giving any kind of restriction, any kind of resistance in the expansion. That is why the answer for this is going to be 0, because whenever we have free expansion, no friction, obviously the answer is going to be 0, because stress is induced whenever strains are restricted partially or completely. So now I will invite Abhinav sir for the next question.
Okay, sir. Okay. So let me take this question, guys. Now we are still dealing with 2019 questions only. Okay, first we'll complete all the 2019 questions, then we'll be going to 2020, 21, 22 and 23. Start easy say, and this is no motive for us for starting easy or difficult. Okay. We'll be dealing with year wise. Okay. And in a particular year, of course, if you want to say that we will be starting with easy questions or we should start, then okay, we'll take care if needed for the upcoming year 2020. Now, this question was asked in 2020 and this is of 2 marks. Now, once the question is in 2 marks, that means that you have to devote some time on that question. Next point before starting solving this question, that GATE is the only examination for engineers which gives roughly 3 minutes for a single question. 65 question, 180 minutes. 65 questions, 180 minutes. That means for every one question, approximately 3 minutes. And if you see aptitude part or 1 marks question part and you separate them, then for a 2 marks question, it is roughly 5 minutes. Roughly 5 minutes. That means GATE will be asking the most conceptual questions as compared to other exams. धीरज sir, मैंने आपको एक message WhatsApp किया है. Okay.
Okay, sir.
Now let us do this question. What is this asked? That there is a horizontal bar, weightless. Even nothing is mentioned in SOM. Every time we considered every beam, every column, every bar to be weightless. Even if it is not mentioned, then also we assume to be weightless. Then 3 vertical members are there, P, Q, R, P, Q, and R. Now, all 3 members have identical axial stiffness. What is axial stiffness? Guys, elongation is PL by AE. Okay. So, what is stiffness? P by delta of a spring. Similarly, what is P by delta here? AE by L. That means this 10 kilonewton per mm is the value of AE by L for all 3 bars. P and R on rigid, and guys, these are rigid frame at the end or rigid floor at the end. Now, when no load is applied, when nothing is acting, there is a gap of 2 mm here. This gap is of 2 mm. Now, guys, what is happening? A vertical load W is placed on the horizontal bar. Here some load is applied and the bar still remains horizontal. That means it is symmetry. That means the load will be applied 100% here. If you apply load here, then load going here will be different and it may not be horizontal. That means it will be applied at the center. And these bars displaced by 5 mm. These bars displaced by 5 mm when we applied load W. What is the magnitude of W? Now in this whole question, only 3 values are given. One is the gap of 2 mm. One, the deflection is now 5 mm. And one is 10 kilonewton per mm. And the value of W is asked. Only 3 values. What is the gap? 2 mm. How much is the deflection or how much the bar is going down? 5 mm. And what is the axial stiffness? So I have just made it here when sir is solving the question so that time can be saved. Axial stiffness is AE by L. So this value is AE by L for all 3 bars. For all 3 bars. Before I start solving this question, किसी भी commando का कोई doubt? Before I start solving this question, any friend have any doubt? Please let me know, guys, and keep sharing the session. Okay. Now, suppose I made the free body diagram of rigid bar. Suppose I make the free body diagram of rigid bar. Now, this is the rigid bar, and in rigid bar at center, the W load is applied. Rigid bar at center, the W load is applied. So from here, bottom, reactions will be coming. If you are pushing it downward, then these 3 columns will be pushing the upward reaction. Okay, then these reactions will be FP, and here it is FQ. Of course, the reactions from FQ will be also be coming because this is displaced by 5 mm. This has gone down by 5 mm. That means the middle bar will be touching. Middle bar will be touching the floor because the gap was only 2 mm. Up to 2 mm, this is freely going down without any providing reaction. But since it is gone by 5 mm, therefore this is also gone by 5 mm. Therefore it is touching here. Therefore it is providing reaction. Now, if I draw the free body diagram of P, Q, and R, everybody, P, Q, and R. Okay, guys, what is my funda for making the free body diagram? That I assume if I'm making the free body diagram rigid bar, I assume that I am a rigid bar. And suppose I'm lying here, somebody is applying W load. So 3 columns will be pushing me like this. That is my funda. I assume that that member whose free body diagram I'm going to make, that is Abhinav Negi. So if Abhinav Negi is here and somebody is pushing me W load here, so from column will be pushing me upward.
Now in this whole question,
Okay. Now, if there are 3 columns and if Abhinav Negi is column, somebody is pushing me from upward. So that push will be coming to me downward. Okay. So if P is Abhinav Negi, it will be FP here. So for balancing, it will be FP like this. Similarly, any doubt, guys, till now? Any doubt till now? Let me tell you, every question requires 3 minutes, but this kind of question, if you are also giving 4 to 5 minutes, it's fine, because aptitude question, 1 marks question, you will be solving in 1 minute also. Now, from symmetry, FP is equal to FR. These both will be same, and let me tell it as F. Let me tell this as F. This FP and FR will be same. Now, what is the deformation of the FP 5 mm? So that means, what is deformation of this? FP into L by AE is equal to 5 mm. What is the value of AE by L? What is the value of AE by L? 10. The value of AE by L is 10. That means FP is equal to FP 50 kilonewton. FP is equal to 50 kilonewton. So this is 50. This is 50. And W is summation of FP plus FPQ plus FR. So W is FP plus FR plus FQ. FP and FR are 50 plus 50 plus FQ. So only we have to find now FQ. Now, guys, this displaced by 5 mm. This displaced by, all are displaced by 5 mm. But when it starts producing stress after the 2 mm, because initially when it is going down by 2 mm, there is no touching. No touching means no reaction. No touching means no reaction. Okay. So this FQ into L by AE is only helping for, is only coming for 3 mm, because 2 mm it is freely going down. This force is coming only to resist that 3 mm deflection. Yes or no? Yes or no? Everybody give me yes or no. Everybody on the comment section. This is deflected. This FP was there for the whole 5 mm. But this FQ is coming only for 3 mm. Initially 2 mm was there was no force. So AE by L is 10. Okay. Or reciprocal L by A is 1 by 10. So FQ is equal to 30. FQ is equal to 30. So this will be 30. So answer will be how much? 130 kilonewton. Guys, now 1 minute extra lag gaya. Lekin batao, samajh aaya ki nahi? Give me yes or no, everybody on the comment box. Put a heart sign if you got it. Put a heart sign if you got it. Okay. Everybody put a heart sign if you got this beautiful question. Now moving to next question. This question number 3, sir has taken. Question number 1 was done. We are still in the 2019 only. We are still in the 2019 only. This question number 3, sir has taken. Now this question number 4. Again 2 marks. And again, as our Dhira sir has told that this is the question. These are the questions where the single digit ranker will be distinguished from all the other students. Okay. These are the questions from where the single digit ranker will be distinguished from other students. Okay, these is also one of those type of question. Okay, just wait. I want to, okay, just wait. Let me delete this. Let me delete. Okay, and let me make it a little bigger. Okay. Now, what is happening here, that a plane frame shown in the figure has linear elastic springs at node H. So this is a node H, and here are the springs Kx and Ky. The spring constant Kx and Ky are given, and K theta is the rotational spring. Some of you have not seen rotational spring, but that can be asked anytime, might be in 2024 also. So I'll be telling you about that rotational spring. Kx, Ky, these kind of springs you have seen. But what is K theta? When the load of 30 kilonewton meter is applied at F point, here 30 kilonewton meter is applied, the rotation observed in the rotational spring here, what is the rotation here, what is the theta here, that is the question, theta h. Okay, now can you please let me know on the comment section that how many of you know that what is rotation spring? Everybody, guys, like in linear spring na, if P, this and this is K, then P is equal to K delta. P is equal to K delta. This is linear spring. Okay. When there is rotational spring like this, then when we apply a movement M, the rotation will be given by M is equal to KT theta. KT is equal to M by theta. So that spring will be very, very strong when theta will be less. For fixed end, theta is 0. So if you are assuming fixed end of a cantilever to be rotational spring, assuming, then that will be of infinite KT value, because theta is 0. So more, less is the value of theta, more is the KT. Similarly here, yeah, less is the value of delta, more is the K. Okay, more stiffness, providing stiffness. Now G is an internal hinge here and applied is 30. What is asked? What is theta h? Let me come here. Theta h is asked. Okay. Now one thing is very sure, that theta h is equal to M by KT. Okay, like delta is P by K. So theta is M by KT. Theta is M by KT. Now what is this reaction? Can anybody tell me on comment box? Let me check that who can do this. What is the value of RE? Tell me on the comment box. Tell me. What is RE? Nobody. In late night, Dheeraj sir has not taken dinner because he was continuous in class. So am I. But students are not replying. What is the value of RE, guys? What is the bending moment at G? Bending moment at G is equal to 0 because at hinge it is 0. So those students who have not studied structure na, please don't be afraid of such type of questions. Those who have only studied SOM, because once you do structure also in your course, or when you study here by yourself, you will be hitting this question like anything. Okay. Now, bending moment at G is equal to 0. So from left hand side, RE into what is the distance? 3, positive, and minus 30 is equal to 0. So RE value is equal to 10. Now, if I cut this FG part, then FG part will be having a reaction 10 here, and a movement 30 here. And guys, summation, whole body is in equilibrium, so small part is also in equilibrium. If whole body is in equilibrium, small part is also in equilibrium. If Abhinav is in equilibrium, my nose is also in equilibrium. It is not going to Khandala. It is also in equilibrium. So if this is 10, this is 30 for force equilibrium, here the internal force will be coming 10. For balancing it, movement will not come. And although movement is already balanced, 10 movement here is 30 clockwise and this is 30 anti-clockwise. It is already balanced. And moreover, in the hinge, no movement can come. Okay. Now, if I draw the GH part, the internal force are always equal in magnitude and opposite in direction. If this is downward, so here it will be upward. Of course, movement will not be coming. And for balancing, here how much will be coming? 10. Here how much will be coming? 10 for balancing. Now here at H point, this is movement I am writing with yellow color. At H, movement of G will be 10 into, what is the distance? 3. 10 into 30 clockwise. So anti-clockwise movement 30 has to come at H. Anti-clockwise movement 30 has to come at H, yes or no? Anti-clockwise movement has to come there. Okay, for balancing, because H here H is not a hinge, na, that is a node. Okay, so 10 into 3, 30. So for first of all, for force equilibrium, 10 upward, 10 downward. For movement equilibrium, 10 to 30, and this 30 anti-clockwise is 0. That movement that movement will not be going here and here. Everything is going to spring. So theta is equal to, kahan gaya? Theta h is equal to m by k. What is m? 30. What is k? K value is given na somewhere. K value is given 3 into 10 ki power 5. So k value is given as 3 into 10 ki power 5. Now calculation कराने के लिए तो यार तुम्हें time waste नहीं करना है. Theta will be coming in radians. From such questions, theta will be coming in radians. All these formulas will theta are for radians. That is how much? 10 ki power minus 4 radians. Guys, do you know that when you usually say for a cantilever where the P load is acting at the free end, theta is PL square by 2EI. If P is given, L is given, E is given, I is given, that theta will be in what? Radian or degree? So if in degrees it is asked, converting in degrees 0.0057 degree. Guys, the formula that you are having for cantilevers, PL square by 2EI, if you apply that formula, P value is given, L value is given, E is given, I is given. So you suppose you got some value 2. Then what is 2? Radian or degree? Radian. Yes. Now this question is also done. Now let us move to this question. So 2019, if I say strength of material level was decent. Even in 21, 22, 23 also, apart from one or two single questions, strength of material level for SOM has been increased. Number of questions are reduced, but level has been increased. Okay, 2 or 3 questions are easy, but although all questions of strength of material are coming difficult. Okay, and once you do structure also, you feel more comfortable in SOM. Okay, now here what is happening that a built-up section, earlier na, it was I section. Earlier na, it was a I section like this. This was a I section. In this I section, here these are built up, these are joined. These on this blue I section, these orange things are joined. On this blue section, the orange figures are joined. But how they will be joining? How they will be joining? By Fevicol or by nails or by riveting? So here they are joined by these red nails. They are joined by these red nails. Actually, this is a cross section. Actually, this is a cross section. If you see in 3D, then this will be like this. And these nails are at 60 mm apart, 60 mm apart, 60 mm apart is given something here. It is 60, 60, 60, it is given where it is given somewhere. 60 mm apart like here. Now what will be the shear force subjected at the level of P? That question is asked. So you have understood the question. Question level was decent. That is why it is asked in 2 marks. Okay. So SOM level is decent in last few years. Okay. Now, guys, what we do here, we find suppose shear flow that is SAY bar by I. And this is unit is Newton per mm or kilonewton per meter or anything. Here 1B is deleted. So when IB is there is shear stress multiplying by length. So here Newton per mm square multiplying by length. It is Newton per mm, force per unit length. So it is SAY bar. Let me take this level of P. So what is the S? It is 8 kilonewton. 8,000. What is A? What is area of this? Area of this is 100 into 50. 100 into 50. What is center of mass from neutral axis? What is the center of mass from neutral axis? Okay, this total is 400. So it is 250 left from bottom. So it is 150. 150. Total is 400. So half is 200 minus this distance. That is 50. So it is 150 upon I. I value is given somewhere. This 1.5 into 10 ki power 9. So this value, I'm not, as far as I'm remembering, this value comes 4 Newton per mm. So this is the shear force per unit length. This is the shear force per unit length. Now, how much length a nail is covering? Guys, after every 50 meters, 60 mm. After every 60 mm, there is a nail. After every 60 mm, there is a nail. After every 60 mm, there is a nail. So one particular nail, if I tell about this nail, this is covering 30 mm of here and 30 mm of here. And so is other nails also. This nail, 30 mm of here, 30 mm of here. So एक nail का कितना राज्य है? एक nail का how much is the area dominant by a nail? How much is the area dominant by a nail? 60, 30 of left, 30 of right. So in per mm it is 4. So in 60 it will be 240. Now actually how simplified I have done it like this. Actually it is a much bigger concept in this. For this particular figure this is happening okay. Actually shear flow has a much bigger concept which I have to derive and tell you about any general session. For that will be taking one session on the YouTube, guys. Don't worry about that. That is very general. It's okay here. But what is the concept behind that? From where it comes, that I'll be telling you. Okay. Now this was now come to question number 6. This sir has done. Hai na, sir? Dheeraj sir, you have done this, na?
Yes, sir.
Okay. Now let us go to another question. Guys, please don't get demoralized by seeing this question. Please don't get demoralized by this question. Please believe me, guys. Believe me, guys. Now, what happened? This was question number 7. What happened when this question was asked in 2019 in 1 marks? No student got it correct intentionally. Kisane tukka mara ho, somebody has done a hit and trial, he might get it correct. But intentionally, no student has done it correct, because to be very frank, including me also, guys, I'm not saying I'm a Rajnikant, including me also, we never tell the shear flow or shear stress for horizontal members, because GATE has never asked. It was not written in the syllabus. Actually, syllabus is, you cannot predict a question from the syllabus. Syllabus plus previous year questions, then only you can predict. Suppose in syllabus it is written as elastic constant. So how do you know that elastic constant isotropic they will ask, or anisotropic or orthotropic? Kahan tak jayenge? Nahi pata. Suppose they ask thermal stresses. So how you know that a question of thermal stress should be determinate or indeterminate? Okay, suppose they last shear force. Then how you know that shear force can be asked for vertical load, horizontal load also? Because for a beam, if this is a vertical load 10, this is 5, this is 5, then if you cut a section here, then cutting a section here, the small part 1, if this is 5, so this internal force, only seeing the force equilibrium currently, it is 5, shear force is 5. But guys, same thing can happen for horizontal loads also. Suppose this is a beam and this is horizontal load. Suppose this is 10. And suppose this is 2 and this is 8, horizontal. So again you cut a section here. Again you cut a section here. Like this. So this is the cross section, and here from here it is 8 load coming. So ye piche wale face mein 8 will be coming like this. That is also shear. If this is shear, tangential, this is also shear. If this is shear, if this is shear, if this is shear, this is also shear. Okay. So how you know? So from syllabus and previous year question, you will get into this, and before 2019 they have never asked this. Okay. So I will be taking a session. If some of you are from our grade up or BYJU'S, I will be telling about this also in your course also at the end of last class. Okay. Okay, Gyanji, okay. Full class topic wise, subject wise, like old days. Okay. Now, guys, first of all, let me tell you that for a rectangular section, how is the shear stress? Like this. Then if here the shear stress is 0, you say that it for the whole width it is constant. If here the shear stress is 0, you say for the whole width it is constant. But suppose if here the shear stress is 20, what you say that here is 20, here is 20, here is 20, here is 20, here is 20. So along the width, you are taking the shear stress as constant. If here the shear stress is 30, you say here 30, here 30, here 30, here 30. Same is the bending stress also. If bending stress is here 15 or 5, and this is the section, you say here 5, here 5, here 5. Suppose here is bending stress 7, so you say here 7, here 7, here 7, here 7, like this. So across the width you take constant. But what is the concept here? When a thin member is there, a thin member, channel section, very thin member is there. Suppose a channel section of very thin member is there. Then across the thickness, across this point, in the depth also, shear stress is taken as constant. Have you got it? Many of you are hearing this statement first time ever, because in most of the books also it is not written. That during the channel section or any section where thickness is very small, then even after in the thickness, these 2 points, these 3 points, or how many points, shear stress is constant. Although we have studied that along the depth it varies. No, here along the width or along the depth it is constant, along the width it is varying. And guys, if you take a section here like this, you have to take a section like this here and you apply SAY bar by IB formula. Only the S is changing, Q is changing across the depth. So it will be a linear function. But when you take in here, when rectangle section, when you take here, AY bar is also changing. AY bar is also changing here. But here only S is changing. So it is a linear function. So always remember this also, when I will be taking about this also, na. So both I'll take a one single session, me and Dheeraj sir, where we'll be discussing this concept, shears, flow, and all these, where we'll be telling you detail. Let us consider restricting myself to PYQ only for this statement. So across the horizontal member, shear stress is linear. Shear flow is, shear stress is linear. Okay. Across the depth, V is also changing and Y bar is also changing. So it is a parabolic function. So, and guys, can you tell me what will be the shear stress at the free end? Everybody on the comment box. Everybody on the comment box. Can you tell me that what will be the shear stress at the free end? What will be the shear stress at the free end? Please let me know. Please let me know. Everybody, come on. This point, free end, it will be 0. It will be 0 and it should be linear variation. So this cannot be there. It will not be constant because Q is changing. How it can be same? Okay. So it cannot be there. So it is linear, and at linear, it should be 0 at the free end. Here it should be 0. And it is parabolic. So C is the correct answer. Remember this statement: for horizontal members, it is linear variation. For vertical members, it is curve variation. That I'll derive somewhere. Although मैंने बता दिया कि यहाँ पे AY bar change नहीं होता. जब section लोगे तो AY bar change नहीं होगा यहाँ पे. So only shear force change होगा. That will be linear. And all these points along the thickness, there is no change. Yes, along the width here it is changing. Give me yes or no, everybody. Give me yes or no, everybody. Okay. Now let me 2019 one question is there. Okay. Okay. So Dheeraj sir will be taking few questions. Okay. कौन सा बच्चा है? जो भी बच्चा है, उसके बाद मैं 2019 के जो क्वेश्चन बच्चे होंगे वो मैं कर लूंगा. कहाँ गया इंटरव्यू क्वेश्चन? धीरज सर आपको बताएंगे. फिर उसके बाद कुछ क्वेश्चन भी होंगे. यस धीरज सर. धीरज सर.
So, sir, first I will take the questions.
Okay, जैसे आप आपकी जैसे मर्जी, आप ही मालिक हैं.
अरे सर
एक बार स्टूडेंट्स सब अपने एक बार सिटी बता दो यार, कौन कौन सिटी से इतनी रात को हमें देख रहे हैं. सिटी एक बार सबके सब बता दो. सिटी बता दो. ठीक है सिटी. ओके धीरज सर.
Okay. So guys, now we are moving to the next question, and as sir have taken some really wonderful questions which were using a lot of calculations as well as wonderful concepts. So guys, now let us see this question. This is once again for 2 marks. So every 2 mark question, if you see, they are not difficult. Some are easy also. Like what sir have taken were very lengthy. This is a very simple question. So guys, for a given loading on the rectangular plane concrete beam with an overall depth of 500 mm. And my dear, you are given the depth. This is 500 mm. The compressive strain and tensile strain developed at the extreme fibers are of the same magnitude. It means the cross section is symmetrical, and you are going to have the strain value to be 2.5 into 10 to the power minus 4. So guys, when we are talking about this strain value, as you know, strain is delta L by L, so it is not having any units here. So when it is given to us and they are asking you the curvature in the beam of the cross section, when this type of question comes, generally students are getting confused between curvature and radius of curvature. I feel you guys are aware that whenever we are talking about R is going to be radius of curvature. R is going to be radius of curvature. And when we are talking about 1 by R, that is said to be curvature. And if you see in the question, they have mentioned the units. So by taking units into consideration, you can feel that they are not asking about radius of curvature, they are asking about curvature. Similar question they have also asked before in 2014 or 15 in civil engineering. So in civil engineering, 2 to 3 times they have asked the curvature. So that is why it becomes very important for you. Now, when you see this, you would be remembering an equation where we are using this concept, that is M upon INA is equals to sigma B upon Y. It is equals to E upon R. So in this equation, you can see our target is this somewhere. So we require this, no doubt about that. But my dear, they have not given us a stress. They have given us a strain. Then also we can have an idea that if we are talking about the stresses and strain, we can have the relation between them. So this part of the equation will be used here. So you will be saying that sigma B upon Y is equals to E upon R. Then, my dear, you would be aware that they are asking about the maximum stress. And whenever we are going to have a beam like this, and if some bending moment is acting, like sir have also shown you the bending stress distribution, the bending stress distributions are coming like this. By looking at this distribution, you can see the stresses are maximum at top and bottom fiber. So they have given the maximum strain. So for maximum strain, I need to take Y maximum. Y maximum is nothing but the distance from the neutral fiber or neutral axis for top or bottom fiber. So my dear, you can write this sigma B upon E is equals to Y max divided by R. But as you need to find out 1 upon R, you can also write it as sigma B. That is also when Y max, sigma B is going to be max. Sigma B max divided by E into Y max. So my dear, you would be aware of one thing, that stress is E times of epsilon, because in the bending you can consider it as a uniaxial loading, and whenever we are having the loading as uniaxial, we can apply this formula, because for biaxial combined we are having the concept of Poisson ratio as well. So I feel, guys, you are understanding the question. Aspirant have answered as well. So when you will be using this concept, sigma B by E can be written as strain. So the answer will be coming by this. This is strain maximum. You can take any tensile or compressive divided by Y maximum. So strain maximum and Y maximum is nothing but the depth by 2. So you will be putting the value as 2.5 into 10 to the power minus 4. And you know what is Y maximum? They need meter. Unit has meter. So you need to put the value. They have mentioned 500 mm. So you will be having this as 500 by 2 into 10 to the power minus 3. So when you will be solving this, here you will get 250. Here it is 10 power minus 3, 10 power minus 4. When you will be cancelling this, you will be getting the answer. I have already solved it for you. Answer is 0.001 meter. So answer is correct for the aspirant, I feel. Okay. Yes, very good, aspirant. The answer is correct for you. Okay. Some other doubts are also there. John, I feel I have answered this on the telegram to you, that which is better. Okay. I feel you are having both the options, which are very much similar and will give you similar kind of things. IIT Hyderabad is a new one, but doing great. So if you want to be in the south side, then IIT Hyderabad would be good. Otherwise, IIT ISM Dhanbad is also good. Okay. So, okay. Now, my dear, we are coming with this question. Okay. With this question, okay, that sir will be taking. Okay. So, GATE 2019 question I have seen. Now, this is the thin cylinder. Okay. Let us see this question. What this question is saying. Okay. Portal frame. Frame, sir will be taking. And this question is also sir will be taking. Sir, are you?
हाँ, आप इंटरव्यू वाले लेने वाले थे ना?
सर आप ही लीजिए, वो साइट इंजीनियर है तो सिविल वाले लेंगे तो ज्यादा बढ़िया लगेगा.
ओके, तो ओके सर,
फाइन सर, आ जाइए.
तो अच्छा, मैंने कैमरा ऑन नहीं किया. ओके, so guys, now what is in between, now we'll be taking some interview question also, because ultimately in few IITs, MTech, PSU, all PSUs, engineering services, you have to give interview also. Okay, so only by technical it will not do. So guys, see, anybody can have a different sign convention. So suppose a drawing come to a site engineer like this, BMD. then how he will be knowing that this will be sagging or hogging? How will be he will be knowing sagging or hogging? And why he should be knowing? Why the site engineer should be knowing that it should be sagging or hogging? Because of course, if this is a beam and it is sagging, okay, it is going to sag, the tension will be at the top. Tension at the top, so reinforcement, steel has to be provided at the top. Why only tension side, not compression side? Because concrete is strong in compression and weak in tension. Why? Because all brittle materials will be having a stress strain curve like this. Okay, in tension they fail very early, but in compression they take a very large amount of stress. So concrete is also brittle. So compression side it's fine. Tension side will be like this. Similarly, if the beam is going to like this, then tension will be here. So reinforcement has to be here. Reinforcement has to be here. So if somebody has given the drawing to a site engineer, like this is plus and this is minus, how he will be knowing? Because sign conventions can be different for different. Sign convention can be different for different people. That is why usually plus minus is not written in the site. Usually the plus minus is not written on the site. Usually what is written like this. This is made. So if this is made, this sign is made. If this is made, then if this is the beam, that means tension is coming at the bottom. Tension is coming, so steel will be provided here. If this is made, the tension is coming at the top, so steel will be provided here like this. So instead of plus and minus, they were using these kind of signs. Okay, we are still in the 2019 only. We are still in the 2019. Guys, what is happening here? See this. A portal frame is shown in the figure. This is the figure. This is the figure. A portal frame shown in the figure has a hinge support at joint P. There is a hinge support and there is a roller at R. So at R there is a roller. Now a point load 50 kN is acting at joint R. Here 50 kN load is acting at joint R in the horizontal direction. The EI value of each member is 10 to power 6 kN meter square. EI is equal to constant for both and is 10 to power 6 kilonewton, 10 to power 6 kilonewton meter square, like this. Now under the applied load, the horizontal displacement of joint R would be, under the point load, what is the horizontal displacement? If you have not studied structure till now, guys, don't worry. Once you do structure, it will be good. Okay, Abhinav sir का छोटा सा fan. Who are you guys? I don't know यार. कौन है भाई आप? कौन हैं आप? Okay, I guess 6-7 months before also I've seen your comment. So this is the thing. Now guys, you know that deflection at any point is del U by del Pn, and it is given by writing the bending moment equation mx, whatever you have written here, bending moment x, differentiate with respect to Pn into dx by EI for the whole beam. This is the deflection, and this deflection is given in the direction of load. So if we take this as Pn, the deflection del U by del Pn will be horizontal only. If this is Pn 50 kilonewton, so what is the reaction? This can provide the horizontal reaction. And guys, this is not the horizontal reaction. This someone is pulling it. Roller support cannot provide horizontal reaction. So here, opposite side, same will be coming Pn. That means 50. Okay, like this. Now, moving forward, what is this RP? So summation of movement about Q is equal to 0. Summation of movement about Q is equal to 0. So this blue is passing from Q, not providing any movement. This RP will be RP into 5 clockwise, and that 50 will be 50 into 10 anti-clockwise is equal to 0. So RP value from here is equal to 500 by 5. That is 100 kilonewton. So this is coming as 100 kilonewton. Okay. Now writing this equation for both parts. Okay, guys, please keep sharing the session. You will get benefit from this, guys. Complete PYQ we are doing. Complete PYQ we are doing in this Maha marathon, guys. Okay, let me do this strain energy part for this orange section first. Let me do this strain energy part for this orange section first, and please check. This is the section RQ. Okay, so here X is varying from 0 to 10. X is varying from 0 to 10. Okay, what is at any section? What is MX? What is bending moment at any section? That is also that is MX also. What is it? 50 into X. Okay, 50 into X. 50 into X. Like this. So bending moment here is 50 into X. Or name it as Pn only, na? Because we have to differentiate with respect to Pn also. Pn into X. Now whatever you have written here, differentiate with respect to Pn. Differentiate with respect to Pn, that is X upon dx into EI, and this is varying from 0 to 10. So from here, taking PA by EI constant, it will be X square by 2, that is 100 by 2, that is 50. So it is P value is how much? 50. So it is 50 into 100 by 2 EI. It is 50 into 100 by 2 EI. Please check. Are you getting the same? This is how much? 0 to 10, na? 0 to 10, na? So 50 into, please, X square, it will be X cube, na? X square integration will be X cube. Okay, so X cube by 3. So it will be 3. X cube will be 10,000. X cube will be 1,000. So 1,000 by 3 EI into Pn. What is this value coming? Can you please let me know? 1,000 by 3 into Pn by EI, whatever value, I'm not wasting time on that. Now doing this, because this formula I have to apply for the whole beam, strain energy is for whole, plus here it is varying from 0 to 5. Let me take a section here at XX. So what is here bending moment at XX? See from left hand side, RP into X. Okay, see from here, the value is RP into X, that is RP, that is 100 into X. Check it, please. Check it, please. Is it coming RP into X or not? Or reaction should be in terms of Pn only. In whatever this method I told you, na, reaction should be in terms of Pn. This Pn should be unique. This Pn should be unique. This Pn should be unique. Other load Pn should not be coming. But here reaction will be coming in terms of Pn. So this is actually 2 Pn. 100 can be written as 2 Pn. So instead of 100x, we can also write 2 Pnx. Okay, so bending moment at X, 2 Pnx. Now, whatever I have written here, differentiate with respect to Pn. So differentiating with respect to Pn will be 2x upon EI into X. Please tell me this value. Please tell me this value. So this is 4 into Pn by EI constant. X square by 2. That means it will be 2. X square will be 0 to 5. It will be 25. So 50 Pn by EI. Please check. Please check. This is coming how much? Please check, everyone. This is coming 1,000 by 3 and this is coming. Please tell me the calculation. 3 EI. I have not done the calculation. 2 Pnx. 2 Pnx is correct. 2 Pnx is correct. Then it is the distance is 2 Pn is correct. Then it is 2 Pnx is okay. Differentiating with respect to Pn. What is the value coming? 2x upon EI. So this is 4 Pn upon 2a x square. It is again x square, na? It is again x square, na? So x cube by 3. Okay, 4 Pnx by EI. 4 Pn upon EI into x square integration will be x cube by 3. So x cube by 3 means like this, 125. So this will be 600 by 3. This will be 600 by 3. So 600 by 3 upon 1000 by 3. How much it is coming? 125 into 4 is 500. Sorry. So adding this, 500 plus 1000 will be 1500. Pn value is 50 upon EI into 3. If you all values are given now. All values are given. If you calculate, this value will be coming as 25 mm. Give me yes or no. This question will take 4 to 5 minutes in exam. This question will take 4 to 5 minutes in exam. That is why I'm saying in last few years, what is happening, that number of questions of SOM has been reduced, but toughness has been increased. Everybody, yeah, come on. Give me yes or no. Give me yes or no now, easy question. 1 marks. Okay, keep sharing, guys. Keep sharing the session so that more and more commandos can join in. Everybody. And Saturday will be same Mahamarathon for serving. Saturday will be Mahamarathon for serving. Then Sunday will be geotechnical last 5 years in the morning, and then SOM will be in the evening. Now, toss, guys, a closed thin wall tube. This is a closed thin wall tube like this. This is very thin. Okay. A mean closed area is AM. And the shear stress tau. Torsional moment of resistance T of the section is T is asked. T is asked. Now say everybody know this formula. Tau by R is equal to T by IP. So T is equal to tau by R into IP. So this tau, IP is tau by R. What is IP? 2 pi R cube T for thin. 2 pi R cube into T. So from here, T is equal to tau into R to R, 2 pi R square. So it is 2 into T. This pi R square is what? Area mean. Pi R square is what? Area mean. So from here, it is 2 tau T, 2 tau T, 2 tau T into AM. That is option number A. Easy question. Let's move to the next question, guys. Everybody, please keep sharing the session. Okay. This is the interview question. This, sir, you will be taking this, na?
No, sir.
Hello?
आप ही ले रहे.
Okay, chalo, my guys, have you seen the highways like this? And lights are in the highways. Now, when these highways are there, what they ask in the interview board, when you see this, area is reducing. Why so? Why area is not constant? Or why area is not increasing at the top? Why it is reducing? Can anybody tell me on the comment box? Can anybody tell me on the comment box, guys? Everyone. Only aspirant is replying. Others are only watching the session, having a fun. Please, please, please. And guys, in this session, in this channel, we are having Super Saturday also. On which on Saturday, we are having the wonderful animated video about a legend or about the automobiles. Now see here what is happening. As we go above, stress is decreasing. Na? As we go above, stress is decreasing, force by area. Because this section has only take this much force. So less area is required. But at the bottom, it has to take complete force. Complete force. So area is also to be more. Otherwise, if you take constant this, so what is the use of this point? Because here force is very less. Why to take this much area? So as we are going above, force is reducing, self weight. So area is also reducing. Otherwise, if you take cantilever also, if you assume it to be, this is on the base of axial stress. If you assume on the base of movement, then guys, the bending moment diagram, this is cantilever and this wind load you can take as UDL. So here is the bending moment is more at the fixed end. So more area is required. Now, sir, 2019 complete हो गए ना?
Yes, sir.
सर एकदम हालत टाइट हो गई मेरी, पसीना पसीना आ गया एकदम, बहुत मुश्किल क्वेश्चन है, कैसे करेंगे बच्चे एग्जाम में? सो 20, अच्छा 20 मेरा ही है ये. सो गाइस सी, इसमें तो दिमाग. ओके, ओवर टू सर नाउ. ओके सर प्लीज.
Okay, guys. So now we are moving to the next question related to the strain energy. Okay. So sir, I have taken some wonderful interview question also for you guys. And now we are talking about this question, which is saying a prismatic linearly elastic bar of length L cross section area A and made up of material with Young's modulus E subjected to axial tensile forces shown in the figure. So this is 1, 2, and 3 cases. They have said when the bar is subjected to axial tensile force P1 and P2, then strain energies are U1 and U2. And U is the strain energy stored in the same bar when axial tensile force P1 and P2 are acting together. For this strain energy U1, for this U2, for this U. And they are asking about the relation. So guys, for this question, like Anubhav have already answered it D. Then he's saying no D, this U is more than U1 plus U2. Fine. So I would like to tell you here, there is a point related to this question. This question is a repeated question. You won't believe, in the civil engineering, it came for the second time. And in XC also it came 2 times. So this is a 4-time repeated question. 2 times in civil, 2 times in XC, but never came in mechanical. So in mechanical, it can come next year. So guys, when you're talking about the strain energy, first of all, you need to understand these three are the different bodies. They are not the same bodies that you will apply the principle of superposition. So if you see the first body, you know that we can write the strain energy as half into P into delta. So when we write half into P into delta, you know half into P delta is PL by AE. So from that, you can see U can be written as P square L upon 2AE. So if we are talking about the very first bar on which the load acting is nothing but P1, it is P1. So you can say strain energy U1 is P1 square L upon 2AE. This is going to be the strain energy 1. All other things are same given to us. Then, my dear, similarly, we can talk about the second bar, which is subjected to the load P2. We can say U2 can be written as P2 square L upon 2AE. So, my dear, when we are talking about the third bar, which is subjected to the force P1 plus P2, for that, if you will write the same formula, it will be P1 plus P2 ka whole square, L upon 2AE. I am not writing in the differential format, otherwise it is Pxx square dx upon 2AE. But as it is not requiring that much things, so you can see here, P1 plus P2 ka square is like A plus B ka square. Yes, so you will be having P1 ka square plus P2 ka square plus 2AB. I feel you may be remembering that one bhashan was there of Prime Minister, India and Canada. Then they have said this 2AB is coming. So the same thing here is coming, 2P1, P2. So my dear, you know that when we are talking about P1 square L upon 2AE plus P2 square L upon 2AE plus 2 times P1, P2 L upon 2AE. So when you will say this, it is coming out to be U is coming out to be U1 plus U2 plus this extra term. So you can say U is going to be more than U1 plus U2. So the answer given by Anubhav is correct. Aspirant is correct. So answer is U is more than U1 plus U2. Answer will be C for this. Very good, Aspirant and Anubhav. It's great. Great. So now we are moving to the next question, guys. This is related to the Mohr circle from 2020 for 1 mark only. Okay, this is easy question. I feel everybody will be able to answer it. The state of stress represented by Mohr circle shown in the figure is it for uniaxial tension, biaxial tension of equal magnitude, hydrostatic stress, or pure shear? What is the right answer for this? Okay, already Aspirant said D is going to be the answer. What about you, Anubhav? What do you feel? Anubhav, what do you feel? Pure shear is asked. Okay, pure shear. Okay, fine. You said for pure shear it is going to be. Means answer is D. So, my dear, if you are talking about uniaxial tension, for uniaxial tension, Mohr circle will be coming like this. For biaxial of equal magnitude, it will be coming out to be this point. Hydrostatic state of stress will be coming point in the negative direction. For pure shear, we are going to have center of Mohr circle at the origin. So answer is correct, guys. And why it is coming, you already know that this is said to be the pure shear. So when this is said to be the pure shear, you can see the state of stress on X phase is 0, this is going to be minus tau xy. So this is going to be the state of stress on X phase. This is going to be the state of stress on Y phase. Joining AB, take C as center, make the Mohr circle. This is going to be the Mohr circle. Okay, guys. So the answer for this is no doubt about that is D. Moving to the next question. This is once again from GATE 2021 mark, easy question. Let us see how many of you give right answer for this. So guys, do like and share the session. In a two-dimensional stress analysis, the state of stress at a point P is this. The necessary and sufficient condition for existence of the state of pure shear at P is. State of pure shear at P is. Okay. So my dear, the state of pure shear, we have just seen Mohr circle comes like this for pure shear. So what do you feel the answer will be? What do you feel the answer will be? Anybody, try to solve it. Okay, aspirant is saying C. You know that I just told you for pure shear, the center of Mohr circle shall come at origin. And for that condition, you also know the coordinate of center is given by sigma star comma 0. And sigma star can be written as sigma xx plus sigma yy by 2. So my dear, when you will say this to be 0, because when it is shifting to origin, it should be equals to 0. So that is possible only when sigma xx plus sigma yy will be equals to 0. So my dear, the answer for this question is going to be C once again. Okay. So I feel everybody got it. Anubhav, aspirant, all others are just watching the session. Okay, they are not answering. So guys, this is one more question from my side. This is from deflection of beams. And here they are asking the deflection at Q and they have applied a bending moment at R. So you need to answer for this question. So my dear, these are the options in front of you. So my dear, for this type of question, you have many options. You can apply principle of superposition also. You can also go for moment area method, conjugate beam method. Choice is totally yours. Okay. So you would be aware of one thing, that the bending will happen till this point. After that, it will follow a straight line. So when that is the case, you can say that this is going to be the deflection at R, and this is deflection at R, and this is the extra part. And as you know, if we are going to know the slope at R, you can also write this part as slope of R into the distance between QR. So when you will add these two things, you will be getting deflection at Q. So deflection at Q can directly be written as deflection at R plus slope at R into QR. Okay, this is one way to solve it. And when you will be solving this, you must be aware of the formula when you will be having a cantilever beam subjected to bending moment, and the length of this is L by 2. So you know, for this, the formula is, if the length is, this is R, this is P, then you know deflection is written as, it is M into PR, the square upon 2EI. This is the deflection of pre-end R. This is coming from the table, what you remember for 8-10 cases. Then if you want to write down the slope of R, it will be ML upon EI. This is ML upon EI. So when you will be putting these values, you will get the answer. Very good. Aspirant said D, and already Anubhav said the answer is going to be 3 ml square means D. For this question, we can apply the same I am saying. I have applied principle of superposition. We can also apply moment area method, conjugate beam method. Choice is totally yours. Okay. Yes. So guys, the answer for this is coming out to be D. Yes, all of you have said D. When I'm checking, I am also having the same answer, I feel so. Yes. 3 ml square upon 8 EI. D is the right answer for this. So this is a very good question. And this type of questions are coming every year in civil as well as mechanical paper. Okay. So guys, moving further. Okay. So let us see one more question. Okay. After that, sir will come. This is, okay, I feel 20 questions are left from sir's side. Sir, are you there?
Yes.
Sir, one question is left for 2020.
Yes. So guys, before I tell you, let me tell you about our channel. This is our channel, hai? And in this video section, what happens, that recorded content will be coming. Whatever the daily dose we are having, okay, daily dose or Sunday ka funda, all these things will be there, like made a mistake in Sunday ka funda. I hope that you have seen this Nikola Tesla video, my favorite video in this channel, okay, of mine. So the Dhira sir has taken Sunday ka funda, Sahu sir daily dose, all these, Joshi sir IOCL. So all these things are there, which are in recorded content, high quality content, like sir has taken James Watt. Okay, this is Super Saturday, है ना? So everything is there. Now in the shorts, you already know live section. We are having the currently PYQ series, and you can see here, ma'am has taken, Chandrasekhar sir has taken. So some more sessions we are going to take in Saturday and Sunday. So please do watch all these. All the Sunday ka funda content where we have done practicaling will be here in the video section. So that is my favorite section among all these three. Here live will be coming. Here shorts will be coming of less than 1 minute duration, and here the recorded videos. Okay, so please do take advantage of this. Like right now also, na, we are taking the session. So here it is coming. Okay. So like this. Now, where is the PPT? इस सब के चक्कर में PPT ना चला जाए भाई. Okay. So let's do some more beautiful questions. Sir has taken already some extraordinary questions. So now, क्या हम apply कर सकते हैं? Okay. I guess yes, you can apply. I have not seen that question, but okay. Strain energy is applicable in almost all part if temperature is constant and support is not sinking. Now my question is, this we have done, this sir has, this is 2020. So my one question is left, na? Yeah, this one. Now guys, there is a load coming here at P. S is a roller support and R is a hinge support. What they are asking, when the structure is subjected to a concentrated horizontal load P at the end T, then the magnitude of support theta R, what is the slope at R? Suppose let me take this as the orange part, okay, and let me take this as yellow part. Now I am drawing the free body diagram of this orange part, and I'll be then drawing the free body diagram of this yellow part. Now this an orange part, everyone please see this. On this orange part, what is happening, that a P load is coming. Okay, so it has to be in equilibrium. So 100% from here, internal force should be coming in opposite direction to make it in equilibrium. It is now in force equilibrium. P right, P left force equilibrium is satisfied, but this P is causing some movement here also. P into L by 2 clockwise. P into L by 2 clockwise. So so anti-clockwise movement will be coming P into L by 2. Now you will say, sir, why you are taking only here? You can see opposite also, na, that this P is causing some movement here. So apply a opposite movement there. No, you have cut a section here. You have cut the section here. वो पूरा साबुत है भाई. You have cut the section here. So cutting the section, where you are cutting the section, there internal force will be coming. Internal force are equal in opposite. So this P right. So here the P will be left. Okay. And this PL by 2 is anti-clockwise. So here it is clockwise like this. Like this. And this is simply supported. Now, simply supported has a standard result that you can derive from various things, area movement, not area movement, you can derive from conjugate, you can derive from double integration or synergy method. That thing is that if a movement is applied, see, simply support, here the movement will not coming, but this is some external, this is not reaction, reaction nahi de sakta hai wo. This external movement is coming, then theta on the opposite side is ML by 6CI. Okay, this you can derive from strain energy method also in just 2 steps. So if M is coming, so here in the opposite end, the theta is ML by 6CI. So here the PL by 2 is coming. So this is R is opposite for that. So what is theta R? ML by 6CI. ML by 6CI. So what is M? PL by 2. What is M? PL by 2. This is M into L by 6CI. So that is PL square by 12VI. That is option number B. So this was asked in 2 marks. So this time is saved now. For other questions which we have taken 6-7 minutes, in these kind of questions it will save time. Okay. So balloon, अच्छा सर जो आपने कन्वे बताया था वॉल्यूमेट्रिक स्ट्रेन वाला बलून वाला डिस्कस सकते सर कर देंगे आज वॉल्यूम वाला सर कर देंगे सर अब 2020 के हो गए 2020 के हो गए नाउ नेक्स्ट इज 21 ओके सर ओवर टू सर पहले बलून वाला ही कर दीजिए बच्चा कुछ बलून कर रहा है
यस सर
फोड़ दो सर आज बलून
Okay guys, so actually this is a question Generally, students are facing one difficulty in this. You must have played with balloon in your childhood. And you know that Poisson ratio when we are talking about the rubber, and it is coming out to be 0.5. So when we are talking about the formula for volumetric strain, which is nothing but change of volume but a volume, it is going to be 1 minus 2 mu upon E into sigma xx plus yy plus zz. When we see this formula, they are asking in the question, find out the volumetric strain for the balloon. So when you put this 0.5 value here, it will be directly coming out to be 0. So when you see this, it is saying that volume is not changing. So my dear, when you are going to fill the balloon by putting air inside it, obviously its volume will change because it will be increasing in size. The volume is going to increase. Then how we can say that volumetric strain is 0? So guys, when we are saying volumetric strain is 0, we are talking about the rubber material. Means whatever is the material of the balloon, for that we are saying that volumetric strain is 0. Inside it, whatever is there, we are not talking about that. Like let us say when we are talking about the balloon, it is having some rubber material like this initially. So when you are having this rubber material initially, so whatever its length is there, thickness is there, circumference is there, that we are going to consider. We are not going to consider the air inside that. Okay, because if you will be considering that, then obviously volume is changing. Volume is not changing for the balloon material. So what is balloon material? You know that rubber, and inside it what you are filling is not we are talking about. So that is the problem when students are facing, and this question have been already repeated 2 to 3 times in engineering services and civil services in mechanical paper also. Okay, so that is why whenever you see 0.5, you directly put 0. You must understand it practically as well. Is it clear now? Yes, fine. So guys, now we are moving to the question of torsion. Okay, so we will be coming on the question on torsion, this question. So guys, in this question, this is from torsion, a solid circular torsional member OPQ. So when we say OPQ, you can see there are 2 members actually, OPQ, and is subjected to torsional moments as shown in the figure, not to scale. The yield shear strength of the this material is 16 MPa. The absolute maximum shear stress in the member is going to be. So here they are asking you about the maximum shear stress. So when they are saying absolute maximum, here this is not about the planes. Here what they are talking about, there are 2 members. Like if this is member 2, this is member 2. This is member 1, this is member 2. You know that tau max can be written as 16T by pi d cube. Okay. So when we are talking about 16T by pi d cube, if you will see the torque in the first member, then T1 is going to be 1 kilonewton meter. Because when you see to the right hand side of the section, only one torque is there. Diameter is going to be this much, 0.08. Similarly, if you are putting D1 is 0.08. So this will give you the tau max in the first shaft. Similarly, when you are going to take method of section for the second shaft, then this 1 and 2 are in same direction. To the right hand side, you are having 1 plus 2, 3. So you can write T2 is going to be 3 kilonewton meter. And similarly, you can find out the diameter 2 is going to be 0.1 meter. So when you will use these values in this formula, you will get the second tau max. Out of those 2, whatever is maximum is the absolute value, because they are the 2 members connected in series. So you will apply the formulas, get the answer. Both shaft will have different maximum shear. You need to tell which one is going to be maximum. Okay, so just solve it. I want to see the answer of yours. Yes, Anubhav and aspirant, try to solve it and give the answer for this. Yes. So it is a numerical answer type question. I have already solved it for you. Yes. Try to solve it. No, dear. They are not asking about angle of twist. Whenever we are talking about the shear stress formula, then shear stress formula tau max is given as, it is T by ZP. It is T by ZP. Okay. So when you will be applying this T by ZP, the answer will be coming out to be 16T by pi d cube. So distance is not coming in stress formula. Distance is coming in angle of twist formula. Harshit Tripathi and Anubhav Singh have given the right answer 15.28. So you will get maximum in which one? First one or second one? Yes, you are correct. Tau max is 15.27. But in which shaft? First one or second one? First one or second one? Second one. Okay. So in this you are getting this, and this is said to be absolute, because whenever we have 2 to 3 maximum things, they are said to be local maxima, and maximum of all is said to be the global maxima. Very good, Anubhav and Harshit. Yes, aspirant, have you done it or not? Moving to the next question. This one, strain hardening. Now we are talking about the strain hardening, stress strain diagram. Strain hardening of structural steel means strain occurring before plastic flow of steel material, strengthening steel member externally for reducing strain experience, decrease in the stress experienced with increasing strain, experience high stress, then yield stress with increased deformation. What is going to be the answer for this one? Yes, so guys, do like and share the session. We are doing 2021 questions now. After that, we will go for 2022 questions. We have completed GATE 2019 all questions, GATE 2020 all questions. Now 2021 is going on. Very good. Anubhav, aspirant have said D is the answer. Harshit, what is your opinion? And e-movie, you can also tell if anything in your mind. Harshit is also saying D, and answer is D only, because when you see the stress strain diagram, it is coming like this. You know, here is the upper yield point, lower yield point, and then it is going to be the ultimate point. So this is going to be the strain hardening region. So here, obviously, stress is going to be more than the yield stresses. And the reason behind that, I feel you are aware that whenever we are talking about strain hardening region, their internal resistance of material increases because of increase in the dislocations movements. Okay, so the answer is going to be D. This is also more related to material size, which you will study in the paper 1 ESC part. Okay, so guys, moving to the next. So I feel, sir, your
Yes,
questions
sir.
are there.
Okay.
Okay, so now sir will be taking.
Okay. So guys, now next question is, where is 2000, this one, 21. Yes, again a tricky question. Again a tricky question was there. Now please see, everybody, anybody has any doubt, they can ask me. Okay, so various theories are there in this question, that this question is wrong, this question is right, this question is partially correct. Okay, but the one of the suitable answer is that there is some load acting. Of course, 100% from all the 4 sides, only shear stress is not acting, because if only shear stress is acting, so if this is gone here, okay, this has gone here and this has gone here, so why not this one? Why not this one? That means some other than shear stress, some other load is also acting. Other than shear stress, some other load is also acting. Otherwise, this member will also be deviated. Now, if I tell you the FBD of PQ member, this is the PQ member. Then PQ member, I'm only going for the horizontal displacement, 20 mm, and here 10 mm. This is 20 and here it is 10. Here it is 10. This is for PQ, this blue one. So by interpolation, assuming it to be linearly varying, then any member which is at the center, maybe alpha beta, any member which is at the center, that is alpha beta, how it will be deviated? Instead of 20, it will be 10. Instead of 20 here, it will be 10. Instead of 10 here, it will be 5. Why like this? Because this end is almost 0 in horizontal. Here, this end has nothing done in x direction. If taking this as arrow, then arrow part has nothing moved. So this is moved by 20, arrow has 0, so this will be 10. This is moved by 10, this is 0, so this will be 5, considering only horizontal displacement. So the horizontal displacement of 0.5, okay, 0.5 meter means 50 centimeter. So 0.5 meter, 0.5 meter, that means exactly at the center. Here, what will be this? Tell me, please. Tell me, please. Everybody. Okay, this is a 1 meter. This is a 1 meter. So this center. So it will be 2.5. It will be 2.5, guys. Give me yes or no, please. This is 10, this is 5. So at the center, it will be from interpolation 2.5, nah? Give me yes or no. Give me yes or no if you have understood this or not. If you have understood this or not. 0.5, 0.5 point. That means here. So here, how much it will be? How much it will be displaced from original position by interpolation? It will be, if you interpolate it, taking this 0, 0 and this as 1. This has where 1. This is 0, this is 1. So at the center, how much it will be? It is 10. This is -5 because opposite side divided by 2. Like this. Everybody please give me yes or no. Everybody please give me yes or no. This is 10 on the right hand side at the center. This is 5 on the left hand side. So center point will be 10 plus -5 by 2. But there are other theories also which is equally correct. They're considering this angle also and all angle also. From that also the answer will be same. Okay. Now, one interview question before I go to other question. Why cork is used in wine? Okay, I'm asking the strength questions. Of course, the one answer is that when it is tilted, so cork is touching that, and whatever by the taste or chemical or whatever, it looks good. It looks good, or it tastes good, or वो पुरानी नहीं होती, or whatever that reason is. But strength of material point of view is cork mu is 0. Mu for cork is 0. That means if a load is applied on this, then it is literally expand, but width wise it is not changing. Lateral strain is 0. That means it will never be having a larger diameter. So the glass will not be break. Because once you are applying a stress, compression or tension, whatever, laterally it can't expand, nor contract also. Lateral strain is 0 because mu is 0. So neither it is expanding, so glass will break, neither it is contracting, so air will go. So both the things is there. Now 2000, this was 21. So this question, now this one. This is excellent question, guys. Excellent. There is a tank which is filled with water. Nice question, guys. Okay. Just imagination is required. Apart from that, no calculation or nothing will be difficult here. Apart from that, if you imagine the question correctly, you can get it. If you imagine the correction correctly, you can easily get it. Now, what is happening here? Please, everybody see that an elevated cylinder water storage tank is shown in the figure. The tank has inner diameter of 1.5. It is supported to a solid steel column. This is steel column of 75 mm diameter, and total height is 4 meters. Take water density is this, and acceleration due to gravity is this. If elastic modulus of steel is given, ignoring the self weight of the tank for the supported steel column to remain unbuckled, the maximum depth is. So guys, PCR according to Euler's theory is equal to n square, but n here is 1 pi square EI upon L effective square. What is load? Weight of water. Anubhav, have you got it now? Should I explain again? I just see your comment. Sorry. Anubhav, have you got it now? Or should I explain again? Okay, otherwise just rewind at the end. You can rewind, and otherwise I will be taking care of your doubt. Don't worry. Now, PCR is this. What is load here? What is load? Weight of water. What is load here? Weight of water. Weight of water is density into rho GH. Sorry, density into volume. So density is rho and volume. Rho G will be unit weight, and volume will be A. A will be pi by 4 inner diameter, because water will be in inner diameter. What is inner diameter? What is inner diameter? It is supported on inner diameter of 1.5 into H. Okay, just you can convert in the proper units. You can convert this in proper units. Is equal to pi square. E is given. I will be pi d4 by 64. And D of what? Of this tank? No, D of column. So D of column is given. Take tell the diameter this. The tank has inner diameter this D here 75. This D here 75. This I is for the column. pi e I L effective. This is a case of one fixed and one free. And one free, the load is there. In one free, the load is there, water load. So what is the L here? 2L whole square. Everything is given unless other than H value. Everything is given other than H value. So H here will be getting 2.7. Okay, this is coming equal to for 2.7. So load should be less. It should be less than 2.7. And according to the range given by IIT 2021, according to the range given by IIT, it was 2.6 to 2.8. 23 is Kharagpur, 22 is Kanpur, 21 I guess Delhi has taken. So 2.6 to 2.8. Have you got it? Now 21, this question, okay. This question, okay. Sir, this question has done, na? Sir, this question is done, na? So
No, sir. No, sir. No, sir.
ये तो आप करेंगे ना?
हाँ सर. आप चाहे तो आप भी कर सकते हैं, कोई दिक्कत नहीं है.
नहीं आप कर लीजिए सर. Okay, now this is y. What will be the curvature? Guys, d2y by dx2. I hope you have seen the double integration method is m by ei. Okay, and sigma by y is equal to m by I is equal to e by r. From here, m by ei is equal to 1 by r, and 1 by r is curvature. Okay, curvature filling means ghumao, turn. Curvature filling means ghumao, turn. If the turn is like this, oh, large curvature, sharp turn, radius is less. Less radius, curvature more. Now this, like this, less ghumao, turn is less, so less curvature. Radius more, curvature less. So 1 by r is m by ei. So 1 by r is d2y by dx2 also. So dy by dx is 2x minus L, and d2y by dx2 is 2. So answer will be 2. Answer will be 2. Kar loge bhai? 1 marks you will get na. Please tell me. Please tell me, everyone, every commander, every chabun. Kar loge? Can you do this? Can you do this? Okay. Now this is sir, and this is 21. Okay, one more question. 21 is there. One, then 22. Okay, so after this, Dheeraj sir will be coming with other questions of 2021. Then we'll be going to the 2022. Ye easy tha, yes. Now, suppose here the load is RG, or take it as PN. Take it as PN. We want the value at G. And if that is PN, we want to find out that what is that value of PN. So what is this? What is this? This will be WL minus PN, so that summation Fy is equal to 0. Okay, upward load should be WL. WL minus PN plus PN is WL. So that upward load is 0. This should be WL, or this should be WL minus PN. WL minus PN. Okay. And what will be the movement? What will be the movement here? What is the movement? This, due to this it is PNL, due to this is WL square by 2. So what will be the movement? Movement will be, due to this it is PN. So here, movement, let me take with other color. The movement here, due to PN, it will be PN into L. So opposite movement should be PN into L. Due to W, it should be WL square by 2. So it should be here, so it will be minus WL square by 2. Guys, see, from summation Fy0, summation M0 in 2 minutes, you can get this. I don't want to waste time in this. I don't want to waste time in this. Okay, with just a couple of steps. With just a couple of steps, you will get it very easily. So this is PN into L minus WL square by 2. Now there are two members. One is this green member, where I am applying strain energy. And one is this, this member. One is this member, where I will be applying strain energy. What I will be doing, guys, please tell me what is the deflection at G, delta G. Since G is a support, so delta G is 0. Since G is a support, So delta G is support 0. Suppose first of all, I know this, let me write the basic formula. Deflection is integration of Pn, whatever the load you are, sorry, it is integration of Mx. It is integration of Mx. Whatever Mx is bending moment at section. Whatever you have written here, differentiate with respect to Pn. Whatever you have written here, differentiate with respect to Pn into Ei into dx. Into Ei into dx. Getting or not? Okay. Now this thing for G I will be calculating 2 times. One for the green one, one for the green one, and one for the blue one. And summation of both will be 0. Summation of both will be 0 because G is a support. Understood till now? Understood till now? Understood till now? Okay. Now, if I calculate first of all for green part, integration 0 to L. What is the load? Load is Pn from right hand side. Pn into X minus WL square by 2. This is the bending moment at that section. Pn into L minus WL square by 2. And after that, it will be differential, whatever written here, differentiate with respect to Pn into X dx upon Ei. Plus this blue part. What will be the blue part? Okay. Take any section from here at X distance. So this will be, this length is 2L. Okay. So this is Mx. Mx is PNL minus WL square by 2. Whatever written here, differentiate with respect to Pn will be L into Ei dx integration 0 to 2L. I'm not wasting time in calculation. Concept is done. Concept is done. Add this equal to 0 and only one variable Pn you will be getting in terms of WL. Pn is the reaction and that you will be getting as 0.482 WL. Pn is equal to 0.482 WL. Please tell me any doubt in the concept. Is okay. I don't want to waste time. Delta G we have find out for this green part and pink, blue part, because this formula of this you have to apply this for the whole. This energy you have to apply for the whole beam. You do this. Give me yes or no. Have you understood? And I'm again telling you guys that this Saturday will be survey. This Saturday will be survey. Okay. Then survey marathon. Then Sunday will be soil mechanics and SOM marathon. Okay, guys. Okay. Let's move forward. This is now 22. Okay, sir. Sir will be taking the rest of the questions of 21. Hello, sir. Okay.
Yes, sir. Okay. So guys, now this is the question, and this question is a propped cantilever beam XY. Okay, they have mentioned it XY with an internal hinge. There is the internal hinge, and you can see that the middle is carrying a uniformly distributed load of 10 kilonewton per meter. This is UDL as shown in the figure. The vertical reaction at support X. Here you need to find out Rx. So guys, if you see this question properly, it is from the concept of compound beam as well. So when we study the compound beam, you know, let us say we are having a beam like this cantilever, and then it is going to be attached with this. This is internal hinge. So as here beams are joined in series, we call it as compound beam. When we are talking about this type of beam, we have already seen that at this point of internal hinge, bending moment is coming out to be 0. It is said to be the point of contraflexor. So guys, if that is the case, what you need to do, you need to find out this support reaction Rx. So first of all, you know that here will be a support reaction Ry. So total load is 10 kilonewton per meter for 4 meters. So you can write the very first equation. You can write the very first equation. Okay, very good. I feel someone giving the answer. So when we are talking about this, first of all, Rx plus Ry, you will put it as 40. This is equation number 1. Here equation is 1, unknowns are 2. So generally some student feels it is a statically indeterminate, but it is not. It is statically determinate. Because my dear, there are 2 ways to find out. One way we are going to use that if we break the beam about this point of contraflexor, or otherwise you can take the moment at this point to be 0. So when you will take summation of moment at this point, let us say this point is B, is going to be 0. So we are going to take the moment from this right hand side. You can write it as Ry into 2 minus 10 into 2 into 1. Okay. And that is equals to 0. That will give you the value of Ry. Getting Ry value, put it into this equation, you will get Rx. Anybody else solved it? Please tell the answer. Okay, aspirant is saying 40 is the answer. And okay, 40 is the answer you are saying. Please check. Okay, 10 is the answer you are saying. So Ry will be 10, I feel, and answer will be 30 for us. Answer will be 30 for us. 30 kilonewton. Is it clear? Yes, very good, Anubhav. Okay, Rx, Ra is 30. Yes, I feel 30 is Rx. What we need to find out is that is 30, no? Okay. Is it correct? Yes, very good. Very good, guys. Moving further. This we have already discussed. Now this question from 2021 for 1 mark. This question says, no issues, Anubhav. This question says the state of stress in a deformable body is shown in the figure. Consider transformation of the stress from XY coordinate system to the XY. Okay, the angle theta locating the x-axis is assumed to be positive. If you want to see this, you can feel it in this way. Let us say we are having a plane like this. Okay, so they have given this angle to be 30 degree. If you see the angle from x phase, it is going to be 60 degree. So I'm making this angle to be 60 degree. So if I say this value is going to be sigma xx, this is given to us as 40. You can see this. Okay. And when we are going to talk about this sigma, this is sigma yy. And they have also given us this. Okay, this tau xy 50 is also given. Means tau theta on this plane is also given. Tau theta is given as 50. And we are also given the normal stress on this sigma theta, that is 120. And they are saying what we need to find out, the absolute magnitude of the shear stress component tau xy. So we need to find out this shear stress component. Okay, what is going to be there? Rest all the given things are in front of you. So for that you need to apply the formula of sigma theta. You need to apply the formula of sigma theta, that is sigma xx plus sigma yy by 2 plus sigma xx minus sigma yy by 2 cos 2 theta plus tau xy sine 2 theta. If you see this question, theta is always taken from the x phase anti-clockwise. Theta is going to be 60 degree. Sigma xx is 40. Sigma xx is 40. Sigma yy is also given as 35.6. This is sigma yy. Okay. So we are given sigma yy as 35.6. So you just need to put the values and get the answer for shear stress. Yes, aspirant, can you find out the value of shear stress? We want the value of shear stress. It is a 1 mark question from set 2. I feel it was not difficult question, but for 1 mark, it was little bit lengthy. So I feel I have solved it for you that as well. So please tell me what is the answer you will be getting. I have given you value. You just need to find out tau xy. All other things are given except this. Yes, everybody. I feel this is going to be the last question of 21. Then we will be having the question from 22. Tell me that. Tell me that, guys. Everybody. Yes, Anubhav, Harshit, aspirant. Sigma xx is 40, yy is 35.6. Theta is 60 degree. Sigma theta is 120. This is given. Sigma theta is given 120. Okay. Fine, guys. Solve it. You can see this theta is also 60 degree. So when you will be solving this, guys, shall I give you the answer? After solving this, you will be getting tau xy as 96.18. Harshit, your answer is correct. Harshit, your answer is correct. Very good. Anubhav, your answer is correct. In the range. Very good. So guys, that is the question from transformation of stresses. Okay. This was the 21. Okay. Now questions from 22 are coming. I will take this question. Sir, basic concept की classes available है. Yes, dear. Actually, there are two series completed. One is startup, which is over. One is ground zero. There you can see some wonderful concepts like stress strain diagram, like Mohr circle, like SFD-BMD solving tricks have been taken by us. Okay, B and Avino sir. So you can watch those series. They are basic level series. Okay, they are available on YouTube. Go for that in the playlist section. Okay, aspirant, I feel 96.1 is correct. Fine. Now we are moving to this question, guys. Once again, from the thin cylinders. The hoop stress at a point on the surface of thin cylinder pressure vessel is 30 MPa. Hoop stress, you know, it is PR by T. That is 30 MPa. And you also know that longitudinal is sigma hoop by 2. And they are asking, what about the absolute maximum shear stress? So I feel you are aware that for thin cylinder, this is sigma 1, this is sigma 2. And sigma 3, we consider it as 0. And when we are going for the absolute tau max, then it is found to be maximum of sigma 1 minus sigma 2 by 2, sigma 2 minus sigma 3 by 2, sigma 1 minus sigma 3 by 2. How it is coming? You know that if this is sigma 1 axis, this is sigma 2 axis, then tau max is coming at 45 degree to both of them. So this is tau max in the plane of 1, 2. So you can write tau max as sigma 1 minus sigma 2 by 2. Okay. This is how, this is the in plane because it is in the plane of 1 and 2. Similarly, if we will be having three stresses, principal 1, 2 and 3, then we will be having three planes, three in plane maximum. So Harshit is saying the answer to be 15. If you see this is 30, this will be 15. So when you are going to find out this, obviously maximum will be coming out to be 15. So answer will be 15. Okay. It can become a MSQ if absolute word is not written. In that case, 15 and 7.5 both will be the answer. If it is MSQ and this absolute word is not written, then you will say this is also maximum shear, this is also maximum shear. Okay, very good. Great aspirant. Wonderful. So moving further, guys, moving further. So I feel now Abhinav sir will come. Sir? Yes, sir.
Okay. तो ये सर 2022 चल रहा है ना?
हाँ सर.
आपका 2022 सारा हो गया कि बचा है अभी?
हाँ 21 पूरा हो गया सर. 22 चल रहा है.
नहीं आपका 22 बचा है अभी कुछ?
सर 22 आई एम चेकिंग. नहीं सर हो गया.
ओके ओके ओके.
आपका ही बचा है.
Okay guys. Okay sir. So guys, now let's go for the 2022. We have covered 2019, 2020, 2021 and 2022. The fourth one is going. Okay. So let's begin. This is the question asked in set 1. This was asked for 1 marks. Okay. This was asked in set 1 and it was asked for 1 marks, that the 0, 0 is this point. This point is 0, 0 and it is asked that where will be the shear center. What is shear center? Can anybody tell me? What is shear center? Please friends, fast. The shear center is the point where if load X, there will be no twisting, however bending may occur. So there are some golden rules. First golden rule is if it will always lies on the axis of symmetry. Second golden rule, if there are two axis of symmetries, here this is also axis of symmetry, this is also axis of symmetry, so this will be the shear center. Like this is a section, this is axial symmetry, this is axial symmetry, so this is the shear center. Like this is the axial symmetry, this is the axial shear symmetry, so this will be the shear center. But always there will not be two axial symmetry. So one more golden rule, although from 3 golden rules you cannot find everything, you have to make the equations in terms of x, y and z, and you have to check that there should not be any twisting. Now, third golden rule is that if a section is made up of 2 narrow rectangles, then the shear center will lie on the junction of individual rectangles. Okay, then the shear center will lie on the junction of individual rectangles. So this is the shear center of this rectangle. So sorry, so axial symmetry of this rectangle. This is the axial symmetry for this rectangle. So this will be the shear center. Similarly, for here, this is the axial symmetry, this is the axial symmetry, so this will be the shear center. Okay. Now, for this particular section that was given in the question in 2022, 2 narrow rectangle plates. So one is this axial symmetry, one is this axial symmetry of this rectangle. So junction is this point. What is that point? X is 0 and y is 3a. X is 0, y is 3a. Anybody who knows the third golden rule can easily find out. Now, various students are confused in shear center that, sir, from first golden rule and second golden rule, only we can find out some regular cross sections. From third golden rule, okay, 2-4 aur kar loge. But sir, if we have learned to some about shear center, how to derive this, how to get the equations and this, guys, the answer I cannot say no, because as from last 3-4 years, nobody has thought the questions will be coming like we have discussed right now. Nobody has thought that this much level questions will be coming. Okay, so it may come, but chances are less. I cannot directly say that it will not come. Okay, so I recommend you that one golden rule, second golden rule, third golden rule, and then some standard results. Shear center of this, shear center of open slit, some standard results you should be remembering. If all other, going beyond that, first you have to cover other topics also. Okay. Now, moving to this question, what is E? E is equal to 2 into G, 1 plus mu. So from here, G value is asked na, G is equal to E upon 2, 1 plus mu. That is A option. Guys, can you tell me that what is the maximum value of G? G max in terms of E. In terms of this question, guys, if you have not come, you might not be seen in any of the previous year question. What is the maximum value of G in terms of E? What is the maximum value of G in terms of E? Please tell me. Please tell me. Everybody? Okay. So guys, for G is equal to this, from here for G max, what is the value of minimum mu for metals? That should be metals, but otherwise it can be minus also. For metals, what is the value of maximum G max? For metals. For metal, this question you might be seeing first time. So it will be E into 2. So maximum G is half of E. Okay. So G cannot be 60% of E or 70% of E. Okay. Have you, any one of you have seen this question earlier? If any one of you have seen this question earlier, please let me know in the comment section. Please let me know in the comment section, everybody. No. Okay. In terms, M lines between 0 to 1. M lines. No, it can be -1 also. And M lines, if you are saying M as Poisson ratio, it lies from 0 to 0.5 for metals and can be minus also. Okay. Now this question sir has taken. Now this question. Okay. Guys, this is one of the hardest question that has been ever asked in strength of materials in last 20 or 30 years. Hardest question. Okay. For this guys, you can do it from Mohr circle also. You can take it from Mohr circle also. Let me just copy and in fact not new slide. Take this one only. This copy and here I should be pasting it like this. Everyone. Guys, here first of all, shear acting on an infinitely small element, sigma z is greater than sigma x. The major and minor principal stress are sigma 1 and sigma 3 respectively. Considering the compressive stress as positive, which one of the following expression correctly represents the angle between the major principal stress and the horizontal plane? Major is sigma 1. Major is sigma 1. One of the most toughest problem in strength of material ever asked. Okay. Might be on top 3. Might be in top 3. Okay. So now please see this. If I draw the Mohr circle, although I'm not doing this from Mohr circle, you can do from Mohr circle also. Guys, the compression stresses will be written. The compressive stresses will be written on the right hand side like this, because compression they have taken as positive. Although there is some little bit ambiguity in this question because shear stress directions they have not given, but this they have given. Compression is positive, where it is written, where it is written, where it is written, where it is written. Compression stress as positive. So they will be right hand side. And which is bigger? Sigma z is bigger. So sigma z will be here and tau zx, considering that to be positive, and sigma x will also be positive. That is why on the right hand side. And sigma x and what? Tau zx. Okay, they will be diametrically opposite if they are at 90 degree. From here, this is the plane which is bigger, sigma 1 or sigma 3? Which is sigma 1 is bigger. So this is sigma 1, this is sigma 3, and they want the angle between these two, this and this. So for Mohr circle also, you can do this. Please listen to this question very carefully, because this is one of the hardest question ever asked in strength of material. Okay. Now, suppose this is the plane here. I cut a plane here, which is the plane of major principal stress. This yellow one is major principal plane. Yellow one is major principal plane. Okay, major principal plane. Now, if I cut this part and seeing it separately here, if I cut this part, please see this question very carefully. One of the toughest question ever asked. And seeing this. So this is the horizontal plane, sigma z and tau zx. This is sigma x and tau zx here, like this. And let this be plane of, this yellow one is the plane of principal plane. Now what is the angle asked? Let me check. It is asked between major or minor. It is asked between the major or minor. Please tell major. Let this be sigma 1. If this is sigma 1 here, major, then according to this question, theta is asked. This theta is asked. Guys, in most of the books, you will be finding the answers from Mohr circle. You can do this also. So in the books from Mohr circle is given, solution Mohr circle is given. That is why I am taking some different method. Might be you are seeing this method first time. Okay. Okay. Now, guys, this theta is asked. Horizontal and principal, horizontal and principal, horizontal and principal. Now, suppose I do summation fx is equal to 0. Suppose I do summation fx is equal to 0. It should be in equilibrium. Summation fx should be equal to 0. Guys, you मजा आ जाएगा यार इस प्रॉब्लम के बाद. इस प्रॉब्लम के बाद मजा आ जाएगा तुम्हें कि भाई मतलब रात आज कामयाब हो गई, इतना जो समय लगाया तो मजा आ गया. So it will be, if in x direction if I show, so let this direction be minus. I'm not saying compression as, you can take plus also here, because summation fx will be 0. You multiply by -1, it will be 0 only. So this I am taking minus, suppose. So minus sigma x into what is that called? Let me name this as BC and this is AB. This is BC and this is AB. So this will be BC into thickness T. This is the force. This is the force BC into T. What is more coming in x direction? The tau zx. This is also minus tau zx, but is acting on which plane? AB into T. And to right hand side, what will be coming? To right hand side, what will be coming? Please tell me. To right hand side, what will be coming? Please let me know. What will be coming? Which force will be? Which force will be compensating this? Which force will be compensating this? So guys, this angle will be how much? Theta. This angle will be theta. Okay, just this line, that will be 90, this will be 91 as theta, so this will be theta. So what is the value here in horizontal component of sigma 1? That is sigma 1 sine theta. Sigma 1 sine theta is the right hand side. What is this? What is this? AC. This is B, this is C, so this is AC into thickness. AC into thickness. From all these, T will be cancelled out. T will be cancelled out. Suppose this sigma x, from everything, BC can be written as what? BC can be written as what? Please check. BC can be written as AC sine theta. I'm converting everything in AC. BC will be AC sine theta. AC sine theta. AC sine, this is theta. Okay. Sorry. This is theta. So AC sine theta will be perpendicular this by hypotenuse. Okay. So that will be BC. Correct. Correct. Plus tau zx. If I want to write AB as AC. So AB as AC, I have done it. AB as AC can be written as AC cos theta. AC cos theta is AB. AC into base by hypotenuse. Yes, it's okay. And it is sigma 1 sine theta divided by cos theta. Now divide by cos theta everywhere. Divide by cos theta everywhere. Okay, here also it should be AC coming, na? Here should also be AC coming so that it can be cancelled out. Sigma 1 sine theta into AC. Oh, this is already AC. Already AC. So one more AC will be cancelled. Sorry. One more AC will be cancelled. What was there? AC. One AC will also be cancelled. So from here, this will be sigma tan theta plus tau zx is equal to sigma 1. See, AC is cancelled. Tan theta. Okay. That is sigma 1. This is sigma x. That is sigma 1. This is sigma x. So, tan theta. Sigma 1 minus sigma x is equal to tau zx. So theta is equal to tan inverse tau zx upon sigma 1 minus sigma x. Tau zx upon sigma 1 minus sigma x. So which is the option? Please check. Which is tan inverse tau zx upon sigma 1 minus sigma x. Tan inverse sigma 1 minus, so what is this? Yeah, the two options are same. So this will be this. Both options are correct. This is the question, guys. This is the level of the question that will even not differentiating a triple digit rank to the single digit rank. This question is differentiating the single digit rank to the rank 1, 2 or like this. Have you understood this? Have you understood this, guys? Please let me know. Please let me know, everybody. This is the level of question. Okay. Now, interview question we have done here. 22, 22, 22. This is done. 22. This is done. Okay, this one. Please read the question. Please read the question. Consider two linear elastic rods HI and IJ. This is HI and IJ. Each of length as shown in the figure. The rods are collinear and confined between two fixed supports at H and J. Okay. Both the rods are initially stress-free, no stress initially, The coefficient of linear expansion is alpha for both the rods. The temperature of Ij is raised by delta T. Here delta T is increased. Okay. The temperature of Ij is raised, whereas the temperature of Hi remains unchanged. Here delta T is 0. Okay. Now an external horizontal force P is now applied at I. It gives alpha is this, delta T is this, B is B. What is B? Okay, less than B is 2 meter, A is 10^6 Newton. Okay. The axial rigidity of Hi and Ij are 2 AE and AE respectively. To make the axial force in Hi equal to 0, here then no force should be coming. No force should be coming. The value of the external force P is required. Guys, suppose this is P and suppose this is RH and this is RJ. So guys, as it is written in the question that to provide the axial force in the Hi equal to 0, that means no axial force. If you cut a section here from left and right, nothing should be coming. If you cut a force here from left and right, nothing should be coming. That means RH value is equal to 0. Force is not coming, temperature is not coming, force is not coming, temperature is not coming, so it will not increase or decrease whatever. Itself it will not increase or decrease. Itself it will not increase or decrease. Itself it, but due to the increase of this, it can increase. Okay. Iska apne mein koi elongation nahi hoga. Suppose my head is like this and my legs are like this. My legs are increased by 2 mm. So my head will be displaced from its position. If my legs are increased by 2 mm, my head will also be changed its position by 2 mm. But my head ka itself, there will be no elongation of my head only. Similarly here, no force, no temperature. So itself length of Hi will be same. Length of Hi initially is equal to length of Hi finally. This is 100% correct. This is 100% correct. Okay. Now, moving further, to make the axial force in Hi equal to 0, the value of the external force P is, what should be the value of P so that there is no movement here, no force here. To the axial rigidity of rod Hi and Ij are 2AE respectively. To make the axial force in equal to 0, the value of external force P is. That means it should not be displaced. If this is also displacing, the reaction can come there. The reaction can come there. So the deformation due to this PL by AE should be elongation due to temperature. Tell me yes or no. The deformation due to P should be the elongation due to temperature. Give me yes or no. Give me yes or no. And what should be the value of RJ? RJ will be equal to P. RJ will be equal to P. Tell me fast. Tell me fast. Have you understood this? Have you understood this? This movement should be 0. Okay, to make the axial force in rod Hi 0, that means no stress is coming. No stress is coming. That means all the load P will be taken by RJ. Nothing will be coming here. Nothing will be coming here. And delta net will be like this. PL by E, elongation of this will be equal to this. Give me yes or no. Because if it is displaced from its position, either it is compression or either it is tension, reaction will come. Reaction will come. Even it is compressed, even it is tension. Reaction will come. That means nothing it is happening. Therefore, the deformation of this P and elongation and alpha delta T both are same. Okay. Now this question, please. Again, it is asked in 2 marks. And they are asking to linear elastic planar structure shown in the figure is acted by 2 vertical concentrated force P and Q. Okay, the horizontal beams UV and WS connected with the help of vertical linear spring of K is equal to this. The fixed supports are provided at U and it is given that EI value P is given, A is given. What is A? Okay. The center such that force Q is applied at the center of WX such that the force in the spring VW becomes 0. No force here. No force here. What should we do? What should we do? Guys, if this is correct, movement of P downward minus movement of W point downward, movement of, in fact, not P, movement of V. Please see. Delta V minus delta W is equal to delta of spring. Okay. If this is going 3 mm downward and this is going 2 mm downward, that means spring is compressed, or spring is compressed by 1 mm. If this is also going 3 mm down, this is also 3 mm down, that means spring is not elongated, not compressed. So this equation you have to apply. And what is the thing? What is the thing? What is the condition? That force Q is applied at the center of the beam WX such that the force in the beam VW becomes 0. Force Q is applied at the center of beam WX such that the force in the spring VW becomes 0. Force in the spring 0 means, force in the spring 0 means that deflection of this P point and deflection of this W point both has to be same. Give me the answer. Give me the answer, please, everyone. Everyone, guys, I have done this in the exam day only, yaar. I have done this in exam day only. Tell me the value of Q such that the magnitude of force Q such that spring will be 0 here. So if you make the spring, this is P, let the reaction be R there. Okay, actually R will be 0 because such that the force in the spring VW becomes 0. It should be 0. And here it should be Q. And this is W. So deflection of this point, P into 2A cube by 3I. And deflection of this point, Q into A square, Q into A cube by 6EI, because 3 into 2 plus theta into A, both has to be equal. Getting all this? Guys, get the deflection of this. PL cube by 3I, whatever is the length, L is 2A. Get the deflection of this point. Deflection of this point is deflection of this P into, or Q into A square, PL cube, sorry, Q into A cube by 3EI. EI is 2EI, 6EI, plus theta into A, and both put them equal, you'll get the answer. Have you understood this? Okay. Dedicated, awesome session going on. Superb energies at. Okay, मेरे को लगा रिचा मैम मेरा लिखेंगी कि super awesome session by धीरज सर and awesome energy by धीरज सर and अभिनव सर. मैंने लिख दिया लास्ट में डेडिकेशन टू स्टूडेंट्स इज फैबुलस. ये डेडिकेशन टू स्टूडेंट की फैबुलस ही है. मतलब यार रात को 1 बजे यूट्यूब आजकल तो जियो ने, वो अंबानी ने पूरा फ्री कर रखा है. तो इट्स सुपर्ब, एब्सोल्युटली. जोक्स अपार्ट, डेडिकेशन ऑफ स्टूडेंट्स इज एब्सोल्युटली फाइन, फैंटास्टिक. ओके सर, ओके सर, तब तक आप मैं बच्चों को ना देखो 2023 गाइस, आई एम टेलिंग यू द सॉल्यूशन. I will tell you solution. Okay, just I'm putting my camera off. I'll tell you where the solution is. Okay, Dheeraj sir, you can take on. Sir, आवाज नहीं आ रही.
Sir, I feel 22 questions are over. We are going with 23 only now.
नहीं, 23 तो होगा नहीं ना सर.
हाँ, तो 22 तो हो चुका सर.
हाँ, done है session. 23 guys, why this is not happening ना? Because 23 session already we have done. Let me show you. 23 session complete we have already done. We will provide you the link at the comment box tomorrow. Otherwise you can search here. Where is 23 yaar? Where is 23? 23 session, all questions yaar we have already done. कहाँ गया?
Complete paper. सर गायब हो गया. ओके, दिस इज, ये है आपके पास आफ्टरनून सेशन और ऐसा ही फोरनून सेशन भी है.
complete solution is there for all questions including SOM also, and same is the forenoon session भी है, ठीक है, वो afternoon था, ये forenoon session है in this channel only, complete 23 paper. Okay, so you can see there, and guys please do watch the Sunday ka funda and that Super Saturday in the video section. Okay, now 23 questions you can do. We'll provide you the PDF in the Telegram. This workshop is 7 key factors. 7 key factors that transforms from the average student, okay, to the gate topper. That I will be telling in a free workshop on 13th June, guys. Please do register for this super duper workshop. Then this is the scholarship test. This will be on 11th of June, Sunday. Even if you don't want to take the course, it's your choice. You can take this and check your performance on the All India level. Now, surveying marathon will be on concert data Saturday. Then this will be Sunday and again Sunday, guys. For all civil students, this is must. The mechanical PYQ, because अपने क्वेश्चन तो करते रहते हो क्लास में खुद से बुक से. This will be very important for all of you guys. Saturday survey, then Sunday SOM and soil both. Telegram is civil biopreneur sir, and average salary for MTech specialization I'm coming soon, and then is MTech worth I'm coming soon again. Okay, so right now 1:10 AM. Okay, धीरज सर आपका भी कोई सेशन थे? Yes, ISRO practice course is coming. ISRO practice course is coming from 10th of June. जहाँ पे धीरज सर एकदम मचा देंगे भयंकर तरीके से. Complete practice from 10th of June. Okay, and best sequence of choice filling for mechanical. That also you can see. Before leaving the session, please give me a few minutes, sir. Okay, भाई पूछो क्या few minutes. Okay, yes sir. Anything? आप कुछ कहना चाहेंगे? रात के 2 बजने वाले हैं.
So guys, I feel I am really impressed to see that still gate is very far away, but students are so enthusiastic कि मजा आ गया रात में भी सेशन लेके. And अभिनव सर की एनर्जी तो वैसे ही एक्सट्रीम लेवल रहती है. So I think guys also have enjoyed the session. So we will be coming up on Sunday for mechanical questions. You will enjoy that as well, and similarly we will plan for XC as well. So be ready for that, because strength of material is very important for all of 3 papers. So out of 3, you are going to appear 2 papers. One is mechanical plus XC or civil plus XC. So it is going to be very important for all of you. Sir, I feel question is for you.
Sir, 1 बज गया, पूरा क्वेश्चन ही दिखना बंद हो गया. रात के 1 बज गए. BMC environment survey, SOM, hydraulic transportation. If I follow these subjects, it is possible to good marks in ESC exam. Absolutely no. ESC exam है ना. बच्चे सारा पढ़ के 2 बार रिवीजन करके भी सिलेक्शन नहीं हो पाता है कभी. और आप मेरे से ये पूछ रहे हैं ESC एग्जाम, जबकि अब से 200 दिन बाद है. आफ्टर 200 days or 220 days will be ESC exam, and before 220 days you are thinking that you will be covering only 50% of the syllabus. Okay, absolutely no choice from this subject. Okay, BMC environment survey, SOM, transportation, 50% भी इसमें तो अगर आपके 100 में से 100% भी आ जाए ना, तब भी फाइनल सिलेक्शन नहीं हो पा रहा आपका. ओके, कहाँ गया जियोटेक, कहाँ गया FM, कहाँ गया हाइड्रोलिक मशीन, पर्ट CPM, स्टील, RCC. मैं तो कह रहा हूँ इसमें आप 100 में से आपके 100 भी आ गए ना 100%, तब भी नहीं हो पाएगा. ओके सर, जॉब कर रहा हूँ, इट्स करेक्ट, लेकिन जॉब करने के साथ आप कट ऑफ कम नहीं कर पाओगे ना यूपीएससी की, या बच्चों को नहीं कह पाओगे तुम भी अब कम मार्क्स लाओ. तो जो सच्चाई थी वो बता रहा हूँ. मैं ये नहीं कह रहा हूँ कि आप जबरदस्ती नहीं पढ़ रहे हो या आप जबरदस्ती हार्डवर्क नहीं कर रहे हो. बिल्कुल भी मेरे कहने का ये मतलब नहीं है. मेरे कहने का मतलब है कि इतने सब्जेक्ट से एग्जाम नहीं होगा. देखो, एक और मैं ना बहुत सिंपल तरीका बताता हूँ. मोटिवेशन में खुद ही ज्यादा बिलीव नहीं करता हूँ, क्योंकि मेरा मोटिवेशन या धीरे सर की मोटिवेशन से आप 10 मिनट के लिए मोटिवेट हो जाओगे सिर्फ. मैं आपसे ये कहता हूँ, जिस भी बच्चे की जॉब है, जिस भी बच्चे की परिस्थितियां खराब है, जिस भी बच्चे को देर में समझ आता है, जिसकी ग्रैस्पिंग पावर बहुत ज्यादा नहीं है, ESC कर सकता है, कोई भी एग्जाम कर सकता है. जॉब के साथ समय नहीं मिल रहा तो भाई आप 2024 के पहले 25 को टारगेट मान लो. लेकिन दिक्कत तो क्या है कि आप 25 को अभी से टारगेट ही नहीं मानोगे, आप 25 को भी टारगेट मानोगे 24 जून में, और फिर मैं यही जवाब दूंगा कि 1 साल में नहीं हो पाएगा. मतलब आप वाली कंडीशन के हिसाब से जिसमें समय नहीं दे पाओगे. तो जिनके पास भी समय कम है, ग्रैस्पिंग पावर है, आप 25 को टारगेट कर सकते हो. अगर आपके पास समय नहीं है, आप दिन में सिर्फ 2 ही घंटे दे पा रहे हो जैसे आप कह रहे हैं जॉब के साथ, है ना, बस शर्त ये है कि 25 टारगेट आज से होगा 23 से, तब जाके अचीव होगा। वो आपकी जॉब के साथ 25 का टारगेट भी 24 से करोगे तो नहीं होगा। धीरज सर मैं कुछ गलत कहा क्या?
नहीं सर, बिल्कुल सही बात है। पर सर वैसे भी आई फील इन सिविल इफ ही इज मेकिंग द टारगेट तो वो वैल्यूएबल है, मतलब क्योंकि अगर आप अच्छी तैयारी के साथ जाओ तो चांसेस रहते हैं।
बिल्कुल सर। तो ये है, ठीक है सर। तो अब फिर सैटरडे संडे को मिलते हैं। ठीक है, थैंक यू गाइस, कीप शेयरिंग। और 20 वो जो मैंने दिखाया था आपको वहां पे आप 23 का पूरा सेशन देख लीजिएगा। ओके, थैंक यू ऑल, टेक केयर।